Hello, good morning, everyone. Welcome to DevFest 2021, the mobile web. Uh, just check here. So, so with us today, we've got a full agenda for this track. So let's see what we've got for you today. So in about 3 minutes, I will first talk with Ivan. Ivan, see how to speed up your web applications for half an hour. And then after that, 11 o'clock, we're going to have another very, very interesting talk with our session with Zakari Powell, flexible cross-platform user authentication with App Gallery Connect. He's our first speaker, Ivan. I'm going to bring him up to stage so he can introduce himself.
Hello, can you hear me all right?
Yeah, we can hear you.
That's
Welcome,
great.
Ivan. Pleasure to have you with us.
Yeah, thank you very much for having me. I thought I was going to get blown away last night with the storm, but luckily, still here today.
Awesome. So, if you, Ivan, before you start, we can just give us a little bit of introduction so the audience would know a little bit more about our exciting speaker today. Thank you.
Yeah. So my name is Ivan. I work at Infinity Works, which is part of Accenture, as a consultant, and I've basically been working, I guess, in this industry for maybe six or so years. Kind of got a joy working on a bit of everything, really, from the cloud to front end, and I guess performance optimization has always been a topic I've been quite interested in. And I guess this talk today is quite a basic introduction of how to speed up your web apps, but more about why it's important to do that, what tools we can use to measure it, and a couple tips and tricks on how we can improve speed. It's a lot to go over in 25, 30 minutes, but I'll try and go through a very high level overview of it.
Awesome. I won't keep you longer than that. The stage is yours. Let me just bring in your.
Cool.
Take it over. Thank you.
Yeah. Well, thank you everyone who's tuning in. Again, my name is Ivan, and today I'm going to talk to you about how to speed up your web apps. This is my first ever talk at a conference, even though it's virtual. It's a bit easier for me. I don't have to get fully dressed, just the top half. But let me just get started. Sorry, that was probably really awkward, and that delay was intentional. So, and I won't do it again. But if you've not heard, a bounce rate is a internet marketing term to kind of for web traffic analysis to indicate a percentage of users that enter a site and then visit that one page and then leave, being a bounce, rather than continue visiting other pages. And some data, some research that Google did is that they noticed that when load time of a page goes from 1 second to 6 seconds, that probability of bounce increases by 106%. So, if that slide previously was a page loading, I would have increased the bounce rate of people, going to this website by 106%. Hopefully I didn't lose a bunch of people watching right there. I promise I won't do that again. The time it takes for a page to load is actually the number one user requirement when it comes to some research that Google did, which kind of makes sense, right? Because the longer you wait for a page to load, you're not consuming the content. The other kind of big requirements were, how well it fits on the screen, they can find the content they're looking for. But without the page loading, without the content actually being on the screen, you can't kind of consume anything. The problem is that the web is becoming heavier and heavier every year. If we look back at the state of the web, back 10 years ago, the average or the median mobile page weight was only 240 kilobytes. But now we're really close to 2 megabytes. And most of that size is be taken up by JavaScript and images. But this is something that we should care about. For example, Google have started to incorporate page experience signals, which include Core Web Vitals, which we'll talk about soon, into their Google search ranking algorithm. This means that pages that are performant and score well on these kind of signals will then score higher on search, meaning that you'll see improved traffic come from Google. But it also means that pages can become eligible to appear in the mobile top stories feature in search. And previously, that was only reserved for sites that implemented AMP. But other than search, there's other benefits from improving speed. We talked about that bounce rate earlier, but businesses haven't seen increased conversion rates when focusing their time on optimizing their page experience. So, for example, Swappy is a company that sells refurbished iPhones, and they focus on lowering their page load times and on their Core Web Vitals, and ultimately that resulted in a 42% increase in revenue coming from mobile visitors, which is pretty huge. So I've mentioned Core Web Vitals a couple of times, but what am I actually on about here? So the Core Web Vitals are a set of metrics that respond to speed, responsiveness, and visual stability. This helps sites focus on the metrics that matter the most, and that is what the Core Web Vitals are. The first one that measures loading is largest contentful paint. And largest contentful paint refers to a paint event, and a paint event is when the browser renders some pixels on the screen. A contentful paint event is when the browser renders some specific DOM elements like images or a block containing some text. So the largest contentful paint is when the browser is when the metric kind of responds to the contentful paint that rendered the most pixels on the screen. And this is measured by the very first byte the page has loaded to the very last largest contentful paint. And this is usually measured in seconds. And ultimately, what we're doing here is we're measuring loading performance. So in this top example, we could see that the Instagram logo is the largest contentful paint. And on the bottom example, so when searching for Larry Page, the description that comes up on Google search is the largest block, the largest contentful paint render. So a good aim to go for is that 75% of our users should be kind of experiencing a largest contentful paint of under 2.5 seconds, but that's not perfect. That's just kind of a good area to measure for, and every website is a bit different depending on what content you're showing. The next one we have is first input delay, or FID. And this is the time it takes from a user interacting with a page, let's say with a click or with a tap, and the time it takes for the browser to actually begin processing that event handler in response to that interaction. So for example, let's say this is a diagram of the main thread, and the page has just started loading up and there's network requests going on and the main thread is getting busy. If the user interacts with the website, let's say when the main thread is processing a task, the time it takes for that task to finish and for the main thread to free up to respond to that browser input, the time between those two events is the first input delay. And finally, we have cumulative layout shift, and this essentially measures layout stability. I'm pretty sure we've all been here where we're on a website and we're interacting with it. We might just about to press a link or a button, then all of a sudden like an advert loads in and it pushes all the content down on the website. That is what cumulative layout shift is trying to quantify, unexpected layout shifts. So we've kind of quickly gone over, why these things matter, what kind of benefits they bring, and what the Core Web Vitals are. But what tools can we use to actually measure this? The first one is the Chrome User Experience Report. And this is actually a measurement of field data from key user experience metrics, or the Core Web Vitals, across the public web. And this is actually aggregated data from users who have opted into syncing their browser history with Google. So this only kind of reports on websites that receive enough traffic. So low traffic websites won't be represented in this data set. So if this is the case for your website, you'll probably have to look into pushing your own kind of key metrics to your own kind of endpoints or your own analytics, which we'll touch upon later. We have Google Search Console, which if you've not used before, allows you to view how your site's performing on search. But within Search Console, you can actually view your you can view your kind of Core Web Vital scores for each individual page. And this data is coming from Crux. So again, if you're not receiving enough traffic, you may not be able to see these metrics in your Search Console. So those two examples, well, Crux kind of represents kind of field data. This is actually real user data. This is the real experience that they're having on your websites. But we can also run Lighthouse. And if you've never used Lighthouse before, Lighthouse is an open source kind of automated tool used for measuring kind of page performance, as well as other kind of audits like accessibility, best practices, and SEO. And you can run Lighthouse just through Chrome DevTools on your website. You can run it locally. There's a CLI command you can use to run Lighthouse. There's also Node module. There's a Node module as well if you want to implement it into pipelines. And this basically allows you to quickly measure your site in a kind of controlled lab environment. And it's kind of key that this is a simulated environment where we simulate kind of device speed and internet connections. And it's not a substitute for your kind of real user data. We also have page speed insights, which kind of brings both the field data and the lab data together. So this page speed insights is a tool that kind of brings in the Crux report, and it runs Lighthouse on kind of Google servers. And it's great for assessing performance at a page level. So you provide a URL and it'll give you the details on that. It provides like good recommendations for kind of non-developers, people who aren't really comfortable using the command line or using dev tools to run Lighthouse. And it also provides you with a bit more of a consistent kind of baseline rather than running Lighthouse from your own machine. So I mentioned that, if your website doesn't have enough traffic, you might not be getting enough field data coming through on the Chrome User Experience Report. So there is actually a Web Vitals node module, which you can kind of bring into your own app. And it's a great idea, even if you do have enough traffic to get data from Crux, to track your own core Web Vitals and aggregate them and display them in your own analytics platform or on your own dashboards. It essentially helps you measure changes, and you can respond quicker to changes in performance. Most web kind of analytic providers do have some kind of built-in support for core Web Vital metrics, but even those that don't should have some kind of basic custom metric feature that will allow you to push, these custom metrics. And it's really easy to do. We've actually done it for one of the clients that I work on over at InfinityWorks. So we've really, really quickly kind of gone through why they're important and the tools that we can use to help us measure performance at a very high level. We can definitely dive deep into this, but again, we just really don't have the time. But what are some of the things that we can actually do to decrease load times? There's a lot to cover here when it comes to this. As I mentioned, it's a massive topic. But what I've done is I've tried to create a sample website to help demonstrate some of the kind of easy things that we can do to help speed our sites up. So I built a very simple kind of news listing website. It's a client-side React app, but it's hosted in GCP cloud storage. And it's requesting APIs that are also hosted in GCP, but I've got that hosted over in America. And the images are also stored in cloud storage. And I've just kind of handpicked some blogs from the web.dev website and just took some images from Unsplash. And with this, I created a website. I've kind of purposely didn't follow best practices. So using Lighthouse, using kind of that lab and controlled environment, I was able to run a performance audit, and this is the kind of score I was getting. And it's not great, right? I'm getting a really high largest contentful paint, and we haven't kind of covered some of these other metrics, but first contentful paint will be the very first contentful paint event. Speed index is the time it takes for content to be visually displayed during the page load, so the timings between renders. We have time to interactive, which is the time the page is fully interactive after it's finished its initial kind of page load. And we have this blocking time, which is measuring the sum of all time periods between the first paint and the time to interactive, basically when the main thread is busy. So looking into this, this is what the user experiences when loading up my website. So you initially get your kind of blank white page, which is quite standard. Eventually, the JavaScript and CSS is loaded. The JavaScript is interpreted, compiled, transpiled, and executed, and that starts rendering in the nav bar. And then an API request from the client-side React app will go ahead and fetch the article data. The article data will come back and will have links to the images. So it will render what it can, and then it will go ahead and fetch these images. And then after 35 seconds, according to Lighthouse, it will eventually load up the whole page, and the kind of image will be rendered. So looking into the Lighthouse audit, the biggest opportunity here was images. My images weren't properly sized. They could be served in the next generation of formats. They needed to be encoded as well. And I also had a lot of off-screen images that were loading in, kind of taking up the main thread, making network requests. So let's go into this. Looking at the images, I'm rendering them in at 300. I was running some of them in at 300 by 225 pixels, but the value that I'm returning, the actual size of the image was over 5,000 pixels wide. And that's incredibly large. No wonder it's almost 6 megabytes. So the first thing I need to do is, I need to properly size these images for the web. And also, like, while it's not massively different, my kind of aspect ratio, I'm rendering the image, and the aspect ratio of the image was different as well, which could cause some problems and inconsistencies in layout. So the first thing I did was I resized the image. So I kind of went for 2000 by 1500, a 4:3 ratio, and resizing it and compressing the image meant I saved about 88%. On file size. And there's loads of tools out there which allow you to resize images and also to compress them. I just used, I think it was tiny JPEG to do that. So that it's still quite a big image. It's 700 kilobytes. When defining my image tag in the HTML, I also made sure I provided the width and height attributes. This ensures that the aspect ratio will be consistent for that image. But serving that large kind of desktop sized image to mobile devices is a bit of a waste, right? That was still a very large image, and I'm kind of going for what's like a one size fits all approach. And what we can actually do is we can serve different image sizes for different image devices. So by providing kind of picture tags, I can actually provide a source and a source set attribute. So what this source set attribute here is, this is just all it is really is a comma separated list of image files, image paths, and their width or kind of density descriptors. And what this does is allows us to serve different images or different image files for different device sizes. So a user on mobile is only going to be requesting the 1000 wide pixel image, and I could have gone even lower, right? I could have added maybe 600 pixels as a density, because 1000 is still quite a large image to be rendering on a phone. There's always improvements to be made. But another thing we can actually do is we can have multiple source sets. So we can provide another source, and in here I'm providing modern kind of next gen image formats, so WebP. So like WebP images are just kind of an alternative to JPEG and PNG. They're usually quite a bit smaller, and most browsers now support rendering it. And if you define your kind of picture tag and your source tags like this, the browser will, if the browser supports WebP, it will render a WebP image, or else it will just fall back to the JPEG image. Because I also now, I know what my aspect ratio is for every single image. I'll ensure that they are always going to be 4:3. I can actually render a placeholder now where the image will render in. And the main thing for this is that it kind of just reduces the cumulative layout shift that we were talking about before. Now, when when the user's waiting for this page to load, they kind of know to expect something to be loaded within that area. Ultimately, this provides a better user experience looking at the performance after making these changes. My CLS score has basically gone to 0, and I've shaved over 30 seconds on my largest contentful paint. Massive savings, because I was serving massive images. But that's not all we can do with images. What we can do is we can support lazy loading our images as well. Now, lazy loading normally requires kind of a third-party library or custom code to do that. But now most kind of browsers actually support this. Most modern browsers support lazy loading. So before I jump into that, before what was happening was all my images that were kind of appearing off the screen, off the device view, were still getting requested. So the network request was still being made for all these images. Let's say there's another 20 images below the fold. And while they won't be getting rendered, those network requests are still taking up some of the main thread time. And what we can do now, though, is we have kind of lazy loading support. And instead, these images that aren't in the main kind of viewport and aren't within the threshold of being loaded will be deferred. So the network request won't be made until your scroll is close to the image, or whatever threshold you've set. And like I said, most browsers actually support this out of the box. All you need to do is provide that kind of loading attribute and provide the lazy value to it. But there are still some browsers that don't support it, and we want to make sure we support most of our users. But it's actually quite easy to just add a conditional in our code to say, hey, does this browser support the loading attribute on image elements? And if it does, we don't need to do anything else. We could always optionally fetch a third-party library, or we could fetch some third-party code some kind of first-party code that we've created for lazy loading. And we can also do this for iframes as well. The loading attribute is both for images and for iframes. What I did was I went ahead and I manually resized and optimized and compressed my images, which isn't a great use of my time. So that there are tools out there that allow us to automate that. So we have like a node module like Sharp, which allows you to resize and process your images, and there's ImageMagick as well, which is another free and open source alternative for converting and editing images. However, you might actually want to consider using an image CDN. So, an image content delivery network are just an excellent way of optimizing your images. You just provide them an image, and then they'll provide you almost like an API that allows you to kind of manipulate those images, serve them in different formats, different qualities, and different sizes to fit pretty much every single use case. It takes the load off you. It's not something that I implemented for my little demo website, but something that you might want to consider when looking into optimizing your images if you haven't got time to implement your own kind of image processing pipeline yourselves. So after all these changes and after adding lazy loading, I personally didn't see a massive time save in adding the lazy attribute onto my images. I think I saved a few hundred milliseconds, if that, on my largest contentful paint. But what I did save was my total blocking time has went down by quite a bit, which makes sense because the main thread isn't having to go ahead and make all these network requests for images. Keeping on the topic though of CDNs, we can actually use a CDN to improve the site's performance by using this distributed network of servers that are kind of located closer to our users, meaning that the users don't have to go all the way to the origin server to request data. So before, for example, my users in the UK would fetch the React page, and then they'd be making an API request all the way to the US. If I put that API behind a CDN though, I'm reducing that kind of round trip time for the user, and instead I can set suitable cache headers on my API responses. So the API, so that data is basically cached in the CDN, and ultimately this basically means that users will be having shorter round trips and connecting to the data a lot faster. The way this actually works is that normally when you're connecting to an origin server, you'll use like the border gateway protocol to find a route to that server and connect to it. And that won't always be the most performant way of connecting to a server, meaning that you'll have kind of network latency and all that kind of stuff that comes with that. Using something like Google CDN, which is what I used, they have a kind of premium network tier, which basically allows you to have really performant routes between your kind of edge locations and the server. So instead of having to do all these jumps and going through an unoptimized path using BGP, I can kind of use like these high traffic lanes, almost like motorway lanes, to allow my content to get to my users quicker. So with suitable cache headers, I was able to increase performance by a little bit. Saved maybe 300 milliseconds on largest contentful paint. And one thing that's a bit harder to test in Lighthouse was that now that I have cache headers and I was caching my JavaScript and HTML content, that will actually be cached on the user's browser as well. So when the user comes for repeat visits, they'll have a quicker load time because they've already fetched the JavaScript and the CSS. This is why, again, using these lab tests are great for testing out your changes, but really we want to be using the field data from the Crux report, or implementing your own pushing these core web vitals to your own analytic platform, so you can actually see the before and after of your changes. Kind of moving on, Another thing that the Lighthouse report was telling me was that I need to enable text compression. This wasn't a snapshot from I think I forgot to take a screenshot of my audit, but this is an example of what Lighthouse will say. And essentially, what I need to do is I need to compress my text files, like my JavaScript, my CSS, my HTML files. And since I was uploading my website to cloud storage, I was just using JSUtil, and that actually had a flag I could just provide and an array of file types that I want to compress. And by adding this -z and my kind of arguments of what files I want to compress, I was able to just really easily ensure that my files were gzipped when up on cloud storage. And this actually brought massive savings. So, there's less data going down the wire, and it gave me a massive boost in largest contentful paint. And I'm getting close to sub 4 seconds now on low end mobiles. But moving on, sorry, haven't got much time. I'll keep up the pace. One of the final improvements I started looking at was reducing my JavaScript bundle size. What I want to do is I want to remove kind of unused JavaScript and look into using more optimized kind of libraries, or looking into perhaps tree shaking to remove kind of dead code. So if you've not heard of tree shaking basically just describes removing kind of dead code or unused code. For example, I was using Lodash to make some assertions on the data. I was importing Lodash with the underscore. I'm using Lodash is a common JS library, and the way I was importing it meant that the version of Webpack I was using couldn't actually tree shake Lodash and remove all the unused kind of functions from there. And I was also using Moment. Moment, if you've not used it before, is for kind of dates and formatting dates. Again, I was only using Moment to format the dates on my article listing. And what I could do is I could actually replace these for different modules. So Lodash ES is an ES modules version of Lodash, and with my version of Webpack, I could actually tree shake that. So I could import the one function that I was using, and same with the date formatter. And that basically meant I reduced my bundle size by about 35 kilobytes, which doesn't sound like a lot, but that is 35 kilobytes compressed. So when that gets uncompressed, that's about, let's say about 100 kilobytes. And that means that's less time. We save a bit on downloading my kind of JavaScript bundle. We also save time on having to transpile and interpret that JavaScript. While I was making that change, I also spent some time looking into adding a bit more of a progressive loading state. So, between the page loading and making the API request, the user just sees kind of a blank page with a nav bar. But what we can do, which is quite easy to add, is I can add like a skeleton loading state, and I can kind of put in a progressive loading app, which doesn't increase the page load time, but decrease the page load time, but it kind of decreases the perceived page load time. It's quite a hard metric to measure. But by doing this, at least the flow of the page loading, you can kind of get an expectation of what will render on the page. And I guess after that, this was kind of my final performance score for mobile. We only went over a few performance tips here. And, at least it's come a long way from the first test, which took over 30 seconds for the largest contentful paint. Now, what I would need to start doing here is looking into more advanced ways of improving performance. And we've got to kind of remember that it isn't performance and optimizing for the web isn't a quick fix. It's kind of small changes that we need to deploy, we need to measure, and then we need to build on top of that and optimize. While I had quite a poor score not poor score, I had an all right score for mobile. My desktop performance was quite good. Desktop PCs nowadays have really good internet connections, and the browsers are able to compile and transpile that JavaScript much quicker. The main thing that we should kind of look back on really is that we need to measure, optimize, and monitor our changes. Some things that I would start looking into after making all these changes would be looking to bundle splitting, optimizing maybe my web fonts that I was pulling in, look into using resource hints, optimizing my kind of server code, optimizing my client-side code. There's a lot of stuff to go over. And Yeah, so this was a whistle-stop tour. We've only really scratched the surface, but everything that I've talked about, if you visit web.dev/fast, every single topic, from what tools we can use, the importance of page speed, is all explained in here, and you can deep dive there if you're interested. But that's pretty much it. Finished now. Sorry, as I try to keep it under the wire. If I don't really use Twitter much, but if you have any questions that I can't get to you now, feel free to tweet at me, and I'll try my best to reply. But sorry, that's it. Thank you very much.
Awesome, brilliant. Thank you, Ivan. That was very, very interesting and really good that you covered that. Let me see if there is any questions in the chat. That probably a couple of minutes in there. If there is anything there, otherwise we're gonna go into our next speaker. I can't see anything.
Yeah, and yeah, I can. What I'll do is if people are interested, I'll bundle my slides into a document, and I'll send
Awesome.
it over, and yeah, we can get that attached to the
Brilliant.
relevant video or whatnot.
Thank you so much, Ivan. Really appreciate you being with us and spending the time, and I'm sure we're going to see you in future events. Thank you so much.
Thank you very much for having me, and thank you for hosting this.
Brilliant. Cool. Thank you.
Thanks.
Have a good
Thanks. Have a nice day.
My friend.
Right. Bye.
Right. Thank you for that. So let me just share again. Tell you what we've got. So our next speaker is Zakari Powell. He's with us here, so I'm just going to add him to here. Another really, really good speaker. He's going to cover flexible cross-platform user authentication, which is an important topic when it comes to development, security, and the rest of it. And he's going to talk about the App Gallery Connect. So without further ado, I hand over to Zakari.
Hello. Excellent. Okay. Brilliant. So hello, everyone. I'm Zakari Powell. Like I said, I am the lead developer advocate for Huawei's App Gallery Connect. App Gallery is Huawei's app store on Android, but App Gallery Connect is kind of all the developer services that go along with building an app. But that isn't just related to Android. A lot of these services are cross-platform. A lot of them work with iOS. A lot of them work with hybrid frameworks. And I think one of the things that, we need to take a look at, because we all face it at some point, is how do we provide a secure, reliable way to authenticate that the user is who they say they are, but also make sure that that experience is pleasant for the user, it's quick, it's easy to do. Because at the end of the day, if the first thing they're probably going to have to do is authenticate. And if the first experience that they have of your application is terrible, that's really not going to help you in retaining that user and retaining that stuff. So let's take a look at that. So if we look at the kind of history of authenticating within, the mobile and also kind of the wider software development space, for quite a long time, we really just had a username and a password. That's how we authenticated. That worked. It was simple enough for the user to do. It was pretty easy. The user could have the same username wherever they signed up, and they probably also had the same password. It was super easy to remember. Why would you do anything else? What could possibly go wrong? Well, it turns out the answer to that is a lot can go wrong. As these services started to become web-connected services, so did the popularity of hacking these web-connected services. It was suddenly very easy for a hacker to take leaked data from one service, one database, and suddenly actually have access to all of your accounts. You'd use the same username everywhere. You'd use the same password everywhere. They only had to access that password once, and they had access to everything. So it was no longer secure. That was no longer a reliable way to authenticate that a user is who they say they are. It wasn't good for the user, and it wasn't good for us as developers, because we couldn't guarantee that they were actually who they said they were. So we thought, right, okay, let's have a look at the next thing. Let's make passwords more complex. Let's make passwords harder to crack. Let's make passwords unique for whatever service they are relating to. While this works quite well, if you do it correctly, passwords can be quite a lot tougher to hack. Maybe not so much now, but certainly in the past, it was very difficult for a machine to break those passwords. But we've lost the ease of access. We've lost the ease of the user doing that. Suddenly, the user has to try and remember a multitude of different passwords, all of which have their own requirements. We could never actually agree on what you need to include in a password to make it secure. So every different company has their own idea of what is a secure password. And so you end up with having to basically have a long list of passwords that you've somehow got to remember. That isn't really very simple. It's not very user-friendly. Yes, it's kind of more secure, but you've lost that simplicity. So the next thing we sort of considered is, what about if a secure password just isn't enough? We've got to a point where computers are very good at brute force methods to decrypt passwords, but there are also other ways that you could get hold of someone's passwords. You could use some sort of traffic sniffing, you could use keyloggers or phishing attempts, social engineering, other hack methods that mean that at the end of the day, it doesn't actually matter how secure your password is. If someone wants to get hold of your password, they're going to do it. So we've kind of gone backwards again. We've reached a point where we're requiring users to use complex, ridiculous passwords, but actually that's not even guaranteeing that they are who they say they are. We've actually not guaranteed that they are the user that is being authenticated. So the next thing that kind of became popular and is still very important today is two-factor authentication. We use some other external means. That might be an email, a text message, a physical key generator like the one on the slide, something to verify that the person is who they say they are. It's an extra step, it's much more secure, and it means that we can be at least more certain that the person is who they said they are. It's unlikely that a hacker has been able to gain access to someone's username, password, and gained access to what other system they're using for two-factor authentication. That's quite unlikely. So that's great. We've figured out, right, that's it. We've solved the issue. We can pack up and go home. But the problem with that is it's still really not a great experience for the user. It's another thing the user has to keep check on. It's another thing they have to remember. And if they need to access the system, they have to have access to whatever the two-factor authentication thing is. I'm sure we've all had the situation where we need to access a system and it's sent a text message to a device and you can't for the life of you remember where you've put your phone. Or even your phone's battery is dead, so you have to charge it and wait for that to happen. Or if you're same as you're using an authentication app, you are reliant on having that other thing as well. So it's not a great situation necessarily for a user, particularly in the mobile space where we want things as quick and as easy as possible. So what does everyone, or most people, nearly everyone, have that is using the internet? They're probably going to have some form of social media. Social media that's more often than not constantly logged in. Something that they're probably using on every device that they use. So a better authentication system is one where the user actually is already using it. They're already authenticated with someone else. The user can then simply, within your mobile application, click on a button, and we're allowing this third-party system to say, yeah, they are who they say they are. We trust them, so you can trust them as well. It provides a really great user experience for anyone that's using your app. And we, as developers, no longer have to worry about the actual authentication. It's someone else's job to worry about making sure they are who they say they are. Win-win, right? That's the best option that we have. brilliant for us. We are developers. We are inherently lazy. We want to do as little as possible. This is a great solution. However, we then impose the question of which services do you support? Which platforms do you choose as your social media platforms? Sure, Twitter, Facebook, LinkedIn, Google, Apple ID, these might be good options, but how do you make sure that there's an option that's suitable for every user that's going to use your app? What about those users that don't actually use social media? They do exist, and quite often they won't, or even they use it sparingly. So therefore, they actually aren't always logged in and would have to go through a login process to authenticate, which defeats the point. You've also got the case where perhaps someone's using a device that they don't have their social media on. Perhaps they're using a work device that has no social media, and they don't want to link their social media back to that device or that application. And there's the trust issue. It's perceived that when you log in with a social media application, you're giving that company your social media details. Quite often, that's not actually the case, and most of these big ones have become quite restrictive in the information they actually give back, which is good. But it's still perceived that you are handing over your social media details. So there has to be that level of trust there as well. How do you get that trust? These are all basically issues that we face when we're dealing with authentication. How secure do we want to go? Which option do we choose? Which social media sites do we support? Do we do two-factor authentication? Do we do complex passwords? They're all issues that we are going to come up with, and none of them are necessarily the right answer or the wrong answer. On top of that, if you're going to support multiple systems, if you're going to support multiple social media accounts, you're going to have to support multiple SDKs. You're going to have to support multiple ways of authenticating. And that can be difficult. That can put a large overhead on your application for something that is really just a small component of your application. You just want to authenticate the user. You just want to know they are who they say they are. You don't want to have to worry about these things. So that is where something like Huawei's App Gallery Connect Auth service can come into play. This service provides a single SDK that allows you to create a uniformed cross-platform, cross-framework user authentication system. The SDKs themselves are provided for Android, and that's not just Huawei devices, that's all Android devices, iOS, and also web platforms as well, with likes of JavaScript. It also supports a lot of the hybrid frameworks like Flutter, React Native, Cordova, and many others as well. And what that means is you can actually use a single SDK for every platform your application supports to handle any type of social authentication or other authentication methods that you want to use. So what options are actually available in the SDK? Well, it's very important to support many platforms. Of course, you want to be able to use the same SDK across all the versions of your application. But it's also very important to give the user of your application as many options as possible to authenticate, to make sure there's an option that suits them. That's why the Auth service does support a really big range of services. It's easily implemented for any of them as well, which makes it very easy for a developer to support. There's first-party options like mobile phone and email address authentication, which provides two-factor authentication. There's third-party options as well, like Apple accounts, Google accounts, Facebook, Twitter, the list goes on. But also, what happens if there is a service that you want to use that isn't supported? Or you have some legacy authentication system that you've been using already. You've got users that are already using that system and you need to continue to support them. Well, we also support the ability to inject your own authentication systems into the framework, which means you can bundle everything, legacy or new, into one framework. So let's take a quick look at how some of these things work and just how easy it can be to actually use these. So by all means, the easiest, the simplest solution is what we call anonymous accounts. They are the easiest to set up. It's one line of code and then a success listener to actually do something with it. They're super useful if you just need to be able to identify a particular user and link activities within your app to that user. But you don't actually need to know anything about that user. You don't need to know the user's name, their identity. You don't need details about them. But you do still need to be able to uniquely identify that user. So you can say that user has done this, this, and this in the application, or this user has done that sort of thing. So that's a really great, simple way to allow users, allow you to capture that data in a way that's safe for users, because they don't have to do anything. You can call this code just when you start up your application. It will sign in anonymously, and every time the user is using the same device to use your application, it will be the same user. It will be registered within the system as the same user. And you have this user object, which allows you to uniquely identify them throughout your processes. It's a great way for just completely doing away with more complex systems when that's your use case. But of course, you do sometimes need, or a lot of time, you do need information about the user. You do want to be able to capture that information. And a lot of users do still want a simple sign up and login process that uses an email address and possibly a password. It's a system they know. It's a system that has been around for a very long time. So we want to be able to offer that in a secure way. And that's where our email and mobile options are available. They both work in very similar ways. So we're just looking at email today. But essentially, we use a two-factor authentication system to be able to verify that the details the user has entered are correct. So when we are registering a new user via email, the first step is to send that new user a verification code. Here you can see kind of a quick example in Kotlin on how to do that. You literally just pass in the email address and you send them the verified code. Then on success listener, you would have the user enter that code. So once they have entered the code back into your application, you can then build an email user, including their email address and optionally a password as well if you want that extra level of security. And then you can basically just use the create user method to register a new user with that email address, with that verification code. And in the background, the system will confirm that that code was in fact sent to that email address and does in fact match. So you don't have to worry about any of that stuff. You know that if this is successful, if this method call is successful, you have the user, it has been created, it has been verified. Otherwise, you'll get some failure callback and you can handle that in whatever graceful way that you want to. Then when you have a registered user with that sort of setup, they can easily log in later on. You can do that in two different ways. You can just have them log in with email and password. So if you don't want to use two-factor authentication in future iterations of logging in, and perhaps your application doesn't need that level of security. Maybe it is just a simple application like a to-do list application or something where it's not sensitive information. You just want to be able to verify the user in a semi-secure way. So you can still use email and password, and you can control yourself the requirements of that password. And again, you sign in, call the sign in method, and if it's successful, you'll get the user object back, which contains all the details you know about that user. The other option is that you can log in with email using a verification code. So the other option is, again, you'd use the verify code that we saw on the previous slide. And once you've got that code, the user enters that code back into your application and you pass that into the authentication provider with credentials with verified code. So from there, you can optionally add the password in as well. And you can kind of decide if you want which parts of that information you need to verify the user is who they say they are. And again, use the sign-in method. And if it's successful, you'll get your user object back to do whatever you need to do with it. So we've had a look at doing anonymously signing in. We've had a quick look at signing in with an email address, but it's very much the same if you wanted to use a mobile phone number, and how you can use two-factor authentication in those situations. But what about social signing in? What about these third-party offerings? How does that work within our framework? So we'll take the example of signing in with Google. Yep, many Android users, for it specifically, are going to have a Google account. And our framework supports you using that account to sign in, and actually supports using that account to sign in on all Android devices. They do not have to have Google Mobile Services installed for that to work. So it's very useful if you are planning to also support Huawei devices, but you want to continue to support logging in via a Google account. So there are obviously a wide range of services that are supported, as I mentioned, and on the website is the full list. But this is just one example, and they're all very similar. You'll see that the code is very, very similar, and you can basically kind of quite easily support multiple different services. So here, when we're going to do the setup, much like with any of the other third-party services, you'll need to define an app ID and a client ID with the Google service. You go through their normal tutorial of doing that and getting that all set up. And then you'll provide those details back into the application in a resource XML file, as you'd expect. If you've ever used any Google services, you'll kind of know that process quite nicely. So once you've done all the setup, you've got your application set up with Google, you've got your IDs back, you've added that into the application. How do you actually use that? Well, we can simply pass in the Google authentication provider into our sign-in method. And this is where I was talking about that they're all very similar. There's a Facebook provider, there's a Twitter provider. This is the only thing that actually changes. So we call this unified signing in because the code is uniform. You can use any provider that you want, and the framework will handle the actual sign-in flow. So for example, for Google, you would then be presented, executing this code, you would be presented with this dialog, which is very similar. I'm sure you've seen it before if you've used an Android device. And you can select the Google account that you want to sign in with. You can add another account. And you'd also, if this was Facebook, you'd be presented with the native Facebook sign-in dialog. And, the users will see it as it is that company's sign-in dialog, which is very important because it adds that level of trust. So once the user has signed in, again, all we're going to get back is the user object with all the user details required. And that's what makes this, again, so uniform, is it really doesn't matter which way a user actually signs in with your framework, with the framework. You're always going to get the same object back with whatever details are available for that user. And again, we can use a failure listener to gracefully handle any failures that might happen. The user might just cancel the sign-in process, or something else might happen. That's fine too. So we've had a brief look at the social side of it, and like I said, it's very similar for whatever third party you want to use. But what about the situation where you do have your own authentication system? We see this most often is, you've already built your application, you've already got a system in place, you have a legacy system that's been used, and now it's time to migrate that system to a more manageable framework like this. How do you continue to support that old system? You don't want to have to require users to make that transition in a certain, they have to maybe re-register, or they have to actually get logged out and then log back in some way. That's not a very good user experience, and we want to kind of minimize those sorts of abrupt changes in our application. We want it to be seamless. So one thing we do offer is our self-authentication system provider. So we can create a provider based off some arbitrary token. So for example, your login system that you currently use might authenticate the user on a server, and then it might produce a JWT. It might produce some kind of token that you're going to pass back to your application. And traditionally, you would then use that token for future API requests or whatever else it is that you might need to authenticate back to the server. Well, in this instance, all you do is you take that token and you inject that into the self-builder provider. That means that that's then actually linked back into the framework. So we then can sign in using those credentials. So when you first do that, it's going to register a user, and you can go on the new system, but using the credentials that the token has provided. You can then obviously add details from your old system into the new system for what information you have about a user, and you can go through those steps. But the point is that you can continue to support your legacy system for as long as you want. But within your app, you're still always going to have that user object. And that's great because that means that you haven't got to deprecate your old system straight away. Users can be moved over to the new system pretty seamlessly and they aren't even aware of it. And it continues to provide a good user experience. So, talking about, you're authenticating with your old system. You've implemented this new framework. You've brought in support for many different services. You've got Google, you've got Facebook, you've got Twitter, you've got email, you've got mobile. Oh, you've got all these services. It's great. People can use whatever they want. What about the users that are on the old authentication system? How do they migrate to a new system? Or what about the situation where maybe a user wants to be able to authenticate in multiple ways? Maybe on some devices, they're not logged into their Facebook account. So actually on those devices, they do need to log in with an email. Or maybe they do prefer to use Google on certain devices and an Apple ID on their iPhone. Maybe they have both. Who knows? How do we do that? Well, we can do that with what we call account linking. So if we want to be able to enable a user to log into multiple ways, first we do have to authenticate that user in one way. So they have to be logged into the system. They have to exist. Once they've done that, we can get that current user, and then we can call the link method to link a new provider to that user. And just like we've seen on all the other methods, all we're doing is passing in a provider, and that provider is deciding what the authentication method is. So in this example, perhaps the user logged in initially with the legacy system. They're logged into your app, and now they say, well, hang on a minute. I can log in with my Google account now. It says here I can do that. That looks much better. I want to do that. So while they're logged into their account, all we do is present them with a link Google account button or whatever you might want that to be. And then we run this code. And this code is going to go through the same process as if they're logging in with Google anyway, like as if they weren't already signed in. So they'll be presented with that dialog that they know. They'll be able to select their Google account. They'll be able to confirm that. And then that account, once that process is successful, that account is now linked back to the same user object. So you also will find that actually, if you look at the contents of that user object, you'll now see that there are multiple providers linked to it with multiple details, and that you can repeat that process as many times as you want. You can enable a user to log in all the different ways that they want, all linking back to the same physical user on the system. This is also really great if you did start using the anonymous login. So you anonymously created a user, and then actually maybe there's something within your application that does require them to provide more information. You don't have to re-register them. You don't have to create a new account for them. You can actually just go back, use the same account, and use this link method to link a new provider. And I think that's the core of what makes this such a great framework to use, because it's all about providing the user with as many options as possible. We're providing the developers an easy way to manage that and make sure that it works across all platforms. All these examples today have been Kotlin for Android, but it's very similar for iOS. It's very similar if you're writing something in JavaScript. So it really can create a universal solution for everything that you need authentication wise. And yeah, I think that's basically all I have to talk about today. I think I hope you sort of enjoyed that. I hope that was useful. But thank you very much.
I certainly have, Zach. That was an awesome session. I've learned a lot myself. Authentication is super important topic. So we've seen here how it works under the hoods and how it takes a lot of overhead from developers into bringing this functionality. So thank you so much for that, Zach. We appreciate you spending the time and being with us. And
Of course.
look forward to see you again in our future events. So thanks again, my friend.
No problem at all. Thank you for having me.
Thank you. Next, we're gonna go for a coffee break for half an hour, and so yeah, just to break the session into our second half of the morning session. So yeah, just grab yourself a coffee and basically be back in half an hour. See you then. Thank you. All right. Welcome back, everyone. Hope you had a good break, had that caffeine fix. So next, we've got a couple of amazing speakers with two great sessions lined up, all the way from Nepal. We've got with us Damodar, who's going to talk about what and how of a responsive and adaptive design in Flutter. So without further ado, I'm going to bring in Damodar to the stage. There you go. Hello, my friend. Good
Hey,
evening.
good evening. Hey, namaste.
How are you? How are you doing?
Good, better.
Good.
I
Welcome and
I
thank you for
just
being with us.
thank you. I'm glad to be here.
Thank you. Over to you, my friend.
Yeah, thank you. Namaste, everyone. I am Damodar Loni from Kathmandu, Nepal, and I'm here to talk about what, why, and how of responsive and adaptive design in Flutter. So, if you do not know Flutter, or if you have not, I hope you have at least heard about Flutter. Flutter is a cross-platform UI toolkit from Google. So Google is the main lead behind Flutter, but it's an open source UI toolkit, and it allows us to develop cross-platform applications from a single code base. Right. So let's start our talk. So I'm Damodar Loni. I'm software engineer currently at Upright.io, and I'm also Flutter and Dart Google developer expert from Nepal. You can find me on Twitter, GitHub at my handle Lohani Damodar. So let's begin with today's topic, that is responsive and adaptive design, right? So what? First, we need to understand what is responsive and adaptive design before we move on to why we need it and how we can achieve it using Flutter. First, we need to understand what it is, right? So talking about responsive design and adaptive design, if you have been to like web development world, you already know what is responsive design, because it's become very common term in modern days, the responsive web design. And it is similar in terms of Flutter as well. Responsive app or responsive design is the one whose layout is tuned for multiple screen sizes. So when we talk about devices, we have mobiles, we have desktops, we have laptops and tablets, we have wide varieties of screen sizes. And responsive design or responsive application is the one that has layout that is tuned for multiple screen sizes. That is, it adapts or it changes its layout according to the screen size that it is rendered on, right? And talking about adaptive design, it's more common when we are talking about cross-platform applications, and web application is a cross-platform in its own sense, because web applications can run on web in desktops, in laptops, in mobiles and tablets. So it's required to be adaptive. But more so when we are developing native application. I'll talk about that in next section when we are talking about why. Otherwise, an adaptive app is the one that can run on different types of devices, right? So that can run on multiple devices, multiple platforms, multiple operating systems. However, even if we run the same application, it adapts to the norms of the each device type. For example, let's say we have a desktop device where there is a different set of inputs like keyboards and mouse, whereas in mobile or tablets, there is a different sets of input like touch, right? So the design has to adapt, app has to adapt according to those norms in order to provide good user experience. Like keyboard inputs and touch inputs both has to be handled well based on the device that it is being rendered on. So that is the adaptive design. Now that we know what, let's talk about why. Why do we need something like responsive design and the adaptive design, right? Responsive design, we already know if we come from mobile or web background, we already know why we need responsive design. It's because our application is run on wide varieties of screen sizes. So we need our design to adapt to each screen size so that users can easily use our application and user experience looks good in each and every screen size. And this screenshots here I have is from a Flutter development. So during Flutter development, if you have been there, if you have done Flutter development, this render or bottom overflow render flex error is quite common. And this happens because the layout that we are trying to render does not fit in the viewport or does not fit in the device that it is running. It might fit in one of the device, but not in the other. So for something like Flutter, where Flutter is a cross-platform framework, right? Flutter enables us to build application from a single code base that can run on mobile, web, as well as desktop. Now imagine the number of varieties of screen sizes that we have. It includes all the Android devices like Android tablets, Android phones, all of them. Even just talking about Android market, we have wide varieties of screen sizes. Then come to desktop, we have laptops, we have 4K screens, we have 8K screens, we have all different varieties of screen sizes there. Again, when we come to web, web can run, Flutter web can run again on mobile, desktop, and all those devices, right? So we have wide varieties of devices. And in each device, same application we are building using a same code base, but it has to feel normal in each and every platform, right? So for each platform that the application is built for, that the application is running on, it should feel normal to the users. It should feel familiar to the users of that platform, right? And not only design, user experience also should adapt to the norms of each platform when we are talking about cross-platform development, if we want to make a successful cross-platform application. Now, first, we have wide range of screen sizes. Again, we already talked about this: mobile, desktop, web. Now, if we combine all these three, then we have all the varieties of screen sizes in the market. On mobile, Flutter supports both iOS and Android, so we have all different varieties from both worlds. In desktop, it supports Linux, Mac, and Windows, so we have another set of varieties. And web, again, comes back to all those devices, because web can run on any of these devices, right? So our application, even though it is built from a same code base, it should be responsive to the screen size for the user to use it effectively. For example, imagine you are using a Flutter application in a TV OS or TV, Android TV. Then it has to feel different than how it is used in mobile applications or desktops, right? So it has to adapt to the screen sizes. Now, another set of difference when we come to cross-platform development is the forms of input, right? We have wide varieties of input devices: keyboard, mouse, joystick, trackball. May not be common, but what are common is when we go to desktop, keyboard and mouse are common. When we come to mobiles and tablets, touch screens are common. Even audio inputs and microphones and voice enabled apps are common nowadays, right? So Flutter application should feel normal to keyboard users when same application is run on desktop, and it should feel normal to touch screen users when it is run on the mobile application. That is why we have a need for responsive and adaptive design. Okay, so we know what is responsive and adaptive design. We also know why we need it, because something like Flutter, we are targeting wide range of devices, wide different platforms. So there are 6 different platforms now we can build using Flutter, and that's huge amount of varieties. All platforms, each platform has their own challenges, has their own set of rules and norms, right? Sorry. So now that we know what and why, let's talk about how. So in Flutter, how do we achieve such platform adaptive designs and responsive designs. What tools and techniques are available that allows us to design an application that feels normal to each different platforms that we are targeting to, right? So Flutter framework itself provides various tools that make design responsive and adaptive. Some of those tools might even feel familiar to the web design world. If you have come from web design, responsive design background, some of those tools might feel already familiar. Otherwise, there are some widgets, there are some other tools that are provided by the framework itself, and there are some other tools that open source world has contributed as well. So we'll look at few of those tools, few of those code examples. As this is a light talk, I have not prepared a demo, but I have some demo code examples that shows how we can achieve such designs. Okay, we'll talk about few of these techniques listed here. So some tools and techniques that are provided by Flutter framework are like platform constants that tell us which platform our application is running on. Like, is it on Linux? Is it on Windows? Is it on iOS or Android? That is one. Next, we have layout builders that gives us layout constraints that we are building upon, we are rendering upon. Also the code example, orientation builder, aspect ratio, media query. And media query is something you are already familiar with. If you have been to CSS world using media queries, it is somewhat similar to that. However, media queries here provide us with different information like the viewport size, orientation, and all those things. And finally, we have fractionally sized box that allows us to define a size of our widgets or our application layout in fractions, so that it always, no matter what screen size it is rendered in, we can take a fraction of the screen. And using these tools, combining these tools together, one with other, we can achieve really adaptive and responsive design. So let's see some of the examples. First is the platform constant. So when an application or cross-platform development framework, when working with those frameworks, it is crucial to know which platform the code is being run on. Even though most of the code run on each platform, there are times when we want to run specific code or when we want to achieve specific design during our development or during our build, so that Android users and iOS users or other system users feel right at home whenever using that same application, right? For example, Android uses a back arrow button that is a bit elongated and that is pointed, right? Whereas iOS uses a simple back button that is just a back arrow. And these kind of platform constants allows us to make those decisions and build our application adaptive to the specific guidelines provided by each of the application. Using these constants, we can build a layout that truly feels native to each platform, so that we can even make separate designs for each platform during our build time, so that when application is built and run on a specific platform, it has a specific designs and a specific set of output, a specific kind of layout is rendered. Okay, next we have layout builder. Layout builder is a widget that provides us with a constraint. And this constraint is based on the parent. So wherever we use layout builder, this might feel a bit new to non-Flutter developers or someone who has never done Flutter before. But if you have done Flutter before, Flutter is just a tree of widgets, just like HTML or web page is a tree of HTML codes or tags, right? So wherever in the body you are using layout builder, it provides the constraint that it gets from the parent. So we don't get the viewport size here. In the constraint, we get width and height of the parent, so that we can build our layout according to the constraints that we are running on or our application is being rendered on. For example, if this widget is used and our application is running on desktop, we get max width less than 600 or we get greater than 600, right? When in desktop, let's say we get greater than 600, then we can render something called landscape mode, where we design a wizard or design a layout in a landscape mode. Whereas if the same application is run on tablet, we can see that max width may be less than 600, and then we can decide to render the same layout in the portrait mode so that we can make a responsive layout. Next, we have orientation builder. So when it comes to mobiles and tablets, orientations are very common things, and user can use our application in portrait mode or landscape mode. And we can use something like orientation builder that gives us the current orientation of the device, and using that we can decide what kind of layout to give to the user or what kind of layout to render. Next, we have what called aspect ratio. So no matter what the screen size is, we can decide to keep certain widgets or certain layouts in a fixed aspect ratio. For example, we can draw this container with a red color with aspect ratio 3:2. So no matter what screen size, screen aspect ratio may be 16:9, 4:2, or anything, but this layout will always render in 3:2 aspect ratio. Next, what we have is the media query. And media query is something that provides us the viewport size of the device that we are running on, or that our application is running on, so that using media query, we can decide on the layout. Using media query, we can build really something really complex that decides like what we do in web. So in web, if we look at the most of the responsive CSS codes, what we do is we use media query, and based on the screen size or viewport size, we decide what kind of layout to paint using CSS. And it's the same here. Using the media query and size given by the media query, based on height and width given by the media query, we can decide to build whatever kind of layout. We can even build something like Bootstrap that adapts according to the media query or viewport size, right? Next, we have what is called fractionally sized box. And here, we don't actually define the exact width and height. We rather provide width factor and height factor, so that whatever screen or whatever viewport size this layout is rendered on, we always get the same width and height factor. This is somewhat similar to aspect ratio, because this also always takes the provided width and height factor, and it always renders in the same width and height factor based on the total heights and width available. Okay. Okay, so these are some of the common tools provided by Flutter framework itself, but there are more tools that you can use. Okay, and some of them are also provided by Flutter framework, like flexible and expanded widgets, where I don't have the code, but you can easily find about it in the flutter.dev. And there are some awesome packages in pop.dev, awesome dependencies that you can add to your application and that you can use to build really responsive and adaptive designs for your application based on each platforms and based on each screen size. And there are some packages like Sizer, packages like Responsive Builder and Responsive Framework. These are some of the popular ones that are most liked by the community. Otherwise, you can find more, or using these tools that I just showed, we can build our own responsive framework as well if we need to, based on our own decisions, based on our own breakpoints that we say, right? So these are everything. And with this, I conclude my talk. I really thank you all for joining in and listening to my talk. And you can find me in all these handles if you have queries. And I hope you got something out of this talk. You understand what, why, and why do we need responsive and adaptive design in Flutter, and how we can achieve those kind of designs and those kind of applications that feel really native to the users of each platform, each device, so that they can use it effectively as well as they can enjoy using it. So thank you. If you have any queries, you can always reach out to me in these networks. Thank you.
Awesome. Thank you, Damodar, for that. Our next speaker.
Thank you. Bye-bye.
Take care, my friend. Thank you. So our next speaker is Maya. She's gonna talk us about some magic. So welcome, Maya. I'm just gonna bring you to the stream. There you go.
So just checking my mic should be live.
Yes,
You
you
should
are
be
live.
hearing me.
Yes,
Excellent.
absolutely.
I'm gonna
How are
see if
you?
I can
How are
get
you
my-
today? Thank you for
I'm
being
great,
with us.
thank you. Yeah. So I think we probably have a little bit of time. Do you want to just talk about some stuff, or would you like me to start early, or what would you like me to do?
Tell us a little bit about yourself.
Okay, so I'm in South Africa. I live
Oh,
just
brilliant.
outside Cape Town. Yeah. And yeah, I've been an Android dev for quite a while, since, I don't know, cupcake days. Even though I didn't start on Android, I started on Java ME phones.
Ah, okay.
So I've been doing that for a while. And at the moment, I'm working at a company called Luno. We're a crypto wallet. You can buy and save and keep your crypto on the Luno app. So that's where I'm working at the moment. So you're getting my intro slide. I've been working at Luno for about 2 years. And from an Android perspective, the things that I really like, I love working in Kotlin. I just had so much fun doing the advent of code all in Kotlin. And I like things like coroutines and testing. And lately, I've been exploring Jetpack Compose, which is super exciting, right? Everybody's doing
Awesome.
Jetpack Compose.
So were you
I'm
a
really
Java
loving that.
developer before that?
C++, Java, some strange languages before that. I wasn't embedded. I studied to be an embedded developer, embedded coding.
Oh, I see.
So I was doing
And
C
what
and
was-
C++ before.
All right.
Mm-hmm.
So what was the driver for the shift to Android?
So let's see. I'm trying to think when it was, around about 2009, around about there, maybe earlier. I was doing embedded code, and then I realized that there wasn't so much opportunity for embedded code work in South Africa because things were being made in China and elsewhere, and the smartphones started coming onto the market. And so I was thinking, right, if I want to write some code on a small board with not lots of memory, but that has the internet and has a file system, what would be a good place to be working? And mobile came up, and so I just shifted my career over to mobile at that point.
Awesome. Thank you for this introduction. I'll hand it over to you. Show us some magic then.
Okay. Right. So you should be able to see my slides, right? So
Yes.
You've got the introduction. I'm Maya. I'm an Android engineer at a company called Luno. And that @Maya today that you see there, that's my Twitter handle. So you can ask me questions afterwards. My talk is titled Magic Sprinkles, Adding Animations to a Jetpack Compose app. So why am I doing this? The reason is that I find that with apps in the old view system, people write apps and then the animations are always an after the fact that you add the animations. And I wanted to see what it would be like if I had an app that's already written in Jetpack Compose. How would I be able to add animations to an app like this? So let's just jump into the next slide. Let's see, is that working? Yes. So before I could do this, what I had to do was actually build an app for myself. So what I did is I built a simplified crypto exchange, but I wanted to make it something slightly different. So I added a Twitter angle to it so that you can see the tweets of your favorite crypto influencer, and then based on that, you can make a decision. So the UI, the user interface of this app, is what I would use for production type of code. The data, however, comes from a view model, and it's completely fake. And you can see what this app looks like. You can see it's got there. That's the screen that you would use to decide if you want to buy or sell, how much of the coin you want to buy. This screen will track the progress of your transactions happening on the exchange, maybe. And then once it's completed, you could go back to your screen where you see the order book. And if you tap at the top here, you'll get the tweet of your influencer popping up. So what I need to say at this point as well is all of the code for this is in an open public repo. I'll put the link in the slides in the end. and I'll also share the link. And that means that all of the examples that I'm showing you here, you can actually go and find them in the repo, and they're in a single commit. So if I'm talking about a particular example, you'll find a single commit with just what's needed to add that piece of animation into the app. So let's just take a step back and look at animation, the 101 of how does animation work. So animation in movies, on television, but also in apps, it's something that changes over time. So if this is your time axis, or these are the frames being drawn in your app, something needs to change over time for it to look like something's moving. So in here, I've got something that's a small little dot that grows to be bigger, bigger, bigger. And in fact, it's changing position, and it's also changing color. So that's the way that you create the effect of animation in an app. So when I started with this whole idea of animations and in Jetpack Compose, I had some questions in my mind. My first question, coming from looking at other animation code like processing, is where is the draw loop? What piece of code is updating the position or the color or the alpha or whatever it is? Where is this draw loop? Now, that's a very functional way of thinking about it. And I know Jetpack Compose doesn't actually approach things in that way, but I still had that question. And then the other question I had was, is it possible for me to customize these animations? It's all very well to say, okay, I want something to fade in or out, but how much customization can I do? And how difficult is this? And then the other thing is, like, if the position changes or the color changes, do I need to calculate any of these interim values? Or how would that work? And then the last question I had in mind was, typically with animations, something happens, you press a button or you change a screen. How do I trigger these animations? How do I kick them off? And what happens around that? How does that work? Or another way to think about this is, what if I wanted an animation that keeps running? What if I wanted, like, I don't know, a little animation on the screen that's just running forever? How would I do that? So with these questions in mind, let us just take a little step further back and have a quick look at Compose. So I don't know if the audience knows Compose. Compose is a new UI framework that's being used in Android. And the way that you build Compose is you have functions, composable functions, and you build like a tree structure of a function. Maybe it's a composable that builds your screen that has sub-functions that you call. And this is all in Kotlin, and you're controlling the logic through these sub-functions with code. So it's only Kotlin, no XML. And the way that you say that you have a composable function is you add this @composable annotation. And what this annotation does, the rest of the function looks exactly like a normal function, but what this @composable annotation does is it's a compiler plugin, and it puts an object in here, which is the composer. And this composer has got the properties that it's got some data structures. We don't need to know about these data structures, but what the composer knows is it knows about the state, and it knows when the state changes, and it knows which of these functions to call, or what it says recompose. So if something changes in a little piece of your UI at the bottom here, and that's the only thing that changes, it will only call this function again. So it has a way to optimize the way that it calls these functions. Another thing to know about Compose is the way that it's built, or the way that you should use it is you should pass the state into the function as a parameter. Like there's some state. So there's this concept of unidirectional data flow. There's some state outside which is sitting somewhere. It may be sitting in the slot table. Some of it may be in a view model, or there's a remember command. There's a state, and the state gets passed in parameters to the composable, and also you pass in a method to get the events out. We're not going to look at the at this path so much. We're more going to look at the state that's coming into the composable. So with this picture of Compose in our mind, you can already see that there is this object that recomposes the screens, and already you can get like a clue that that draw loop that I was thinking about, it's possible that this composer, because it knows the state, can manage that draw loop. So the next thing I did was, now I had these questions in mind, I have an understanding of how Compose fits together. I went to the Animations API and I made a sketch note of what exactly is happening inside the Animations API. So In the API, there's some top level easy ways to add animations to your app. These are just like if you want to do most common cases, there are simple composable functions that you can just add to your app and you can do things with them. The 4 main ones here are, like, I'm going to take them one by one. So if you have a situation where the screen does not have a composable on the screen, but you want to make it appear. So while there's a bunny here, this is like a magician. There's no bunny and it makes the bunny appear and the bunny disappears. So if you want to have, if you have that use case, you would use animated visibility. So you would wrap your composable that needs to appear or disappear inside an animated visibility composable. So the next common scenario would be, I have one composable, in this case it's the heart card, and I have another one, the diamond card, and I want the heart card to disappear and I want the diamond card to appear. So you have 2 composables and the one disappears and the other one appears. So that's like a crossfade. In music you have crossfade, but for animations you have crossfade as well. And for that there's a simple crossfade function. So you don't have to worry about what this looks like. I'm going to show code examples of how to use this. The third common scenario is if you've got a composable, it's got some other content, like in this case, it's a rose picture, and maybe the rose picture is changing to a coin picture. And so if it's just the content of the composable that needs to change, a good composable to use for that is animated content. And the last common scenario is if you've got a composable that is a certain size. So maybe this text it's a text box, it's got size high, and then some other state changes, something comes in from your view model or something changes, and the size of this composable changes to being something much longer, then you could add a modifier and use animate content size on that. So those are the most common easy scenarios. So the next level deeper inside the animation API is, what if I've got something that's, say, one color and I want to change it to another color? So, or one size and I want to change it to another size. So the API provides a family of functions. The star here, there are multiple ones of them, animate something as state. So it could be animate color as state or animate float as state. So if you've only got one parameter, you can actually use this function to get the interim parameters to be able to do a single parameter change, color change. But what if there are more parameters or more variables that you want to change at the same time? So maybe you want to go from blue to yellow, you want to go from small to big, and you've got some floats that changes this triangle to a star. So if you want to coordinate multiple values, you create a transition, in this case an update transition, and then you get these different sub values you get from the transition, and the transition will coordinate all of these parameters and make them change at the same time and be in sync with each other. And then there's another kind of a transition, which is an infinite transition. So this would be useful for that case where I said, where if you want to continually have a loop, have an animation that runs in a loop, you would use an infinite transition. And again, in a similar fashion to this one, you would have children and the parameters would change with that. There are some other more lower level functions, but because this is a short talk, I'm not going to go into their detail. So now going back to this graph, okay, so I know now how I can change some of these parameters, but the shape of this graph, how quickly this changes over time, will affect what the animation looks like. So is it smooth? Is it bouncy? Does it change quickly? Does it go slowly and then go quickly? I mean, the shape of this. So is it possible to change the way the animation is specified, basically? So in the API, there's an interface called animation spec. So, and that's all of the other animations can take an animation spec. And the animation spec, by default, if you don't specify anything, you're going to get a spring. A spring is like, it's physics-based and it gives a sort of a bouncy effect. If you don't want a spring, if you want to modify this, then you can override the animation spec, and then there are some options. The first one I'm mentioning here is a tween. It comes from the word between, and it's because a value can change in a linear fashion from one value to the next. So the animation will change between these two values. If you don't want a linear change, and you know that at a particular timestamp, the value needs to be a particular value, and at another timestamp, it needs to be a different value, you can set up a keyframe, and that's the keyframe animation spec. And then you actually provide these points, and you get a non-linear way that the animation works. I have an example of this we can show you in a bit. And then there are others, infinite repeatable for the circular animation. And I'm not going to go into the rest of the API because this is all we need for us to get some examples. So the first thing to show, here's my first example. I've got this tweet, you tap on it, it goes to the network, it fetches the next tweet, and I want it to crossfade because I've got one composable, that's the loading, and one composable, that's the tweet card, and I want it to crossfade. So if you want to look at these slides later and you want to see in the app, the merge request number 4 is the one that has all of this code in it. So now let's look at the code. So if I look at the code here, the code I would have had without any animations, I would have had some other state indicating whether the loading indicator must show or the tweet card must show. So this not so bold code is the code that would have been in my code anyway, without animations. Now, if I want to do the crossfade, all I need to do is call this crossfade function, the same as that I showed a few slides back. And then I just wrap the normal logic here with this crossfade function. Over here, I'm saying that it's this state variable that I'm responding to, and it will give this state variable in here. And then here you can see the first time I'm using an animation spec. Now, if I left this out, it would have crossfaded with a spring, but here I'm putting a tween in and I'm saying it needs to take 2 seconds to do the crossfade. This is particularly long, but I made it especially for the slide so we could see what's happening. So what you can see here is that it's very declarative. All you say is that I want a crossfade, and it actually just wraps existing code. So it's not very difficult to add to code that you already have. Let's take another example. So here I've got a very nervous buyer. They don't know if they want to buy, or maybe they're a seller. And if they're changing their mind about buying and selling, this button at the bottom, I don't want it to flash red and green. I want it to change color slightly and slowly from the one color to the next. So what we can see here, it's one value. It's one particular value that changes, not multiple. So I'm expecting to use that animate something as state function. And in fact, if I look at the code, I'm using animate color as state. So I have a value, a button color, and this animate color as state will change the button color slowly between either the buy color or the sell color. And here again, animation spec, and it's going to take 1 second to change from the one color to the other color. So with this color changing slowly, all I can do now is I have the normal button that I would have had. Over here, I might have just put a button color in, but because I'm getting it from button color here, it's passed into this composable as a state variable. And the composer will recompose this button every single time there's a new color value coming into this button. So here you can see in the code how the composer is actually the draw loop that makes the button color change. So that's the one color, one parameter change. So now here, this looks a little bit more complicated. What I wanted here was a little pie chart, and the percentage of coin that you traded needs to fill in. And this, the way this pie chart fills in, I wanted to animate. So this looks like it's a little bit more complicated. But if you think about it, it's only really one value that's changing. It's the percentage in this pie circle that's changing. So if I look at the code, again, animate float as state, it's one value, and it's a float this time. And it's animating towards the percentage that I just got from my view model. I get a current percentage. This is the percentage that's going to change slowly over time by this function. And in my, where I draw my little circle, my little pie chart, I draw the outside circle, and then here where I'm drawing the arc, the sweep angle, I just feed in this current percentage. And again, the composer will recompose this circle and draw the pie, animate the pie and fill it. So now let's do something a little bit more complicated. In this example here, I want it to be an infinite loop. The colors are changing. You can see it's going from orange to black, and also the size is changing. So I've got two parameters that are changing, and I need it to run infinitely. So it's scale and color. So if I look at the code, I make this, remember, infinite transitions. So the transition's going to track two values, the size, scale, as well as the color. How that would look is I've got the size here. I'm animating, I'm saying, give me this transition and animate the float value. Start at 0.5, end at 1.5. The animation spec is infinite repeatable, which means it's going to loop. And I tell it it must reverse. So what that means, it goes from small to big and then from big to small. So that's going to give that sort of pulsing effect. The color is exactly like this, except it's got colors instead of floats. And then what you do is you feed this size and this color into the modifier and into the color of the text. And then the text will be recomposed as the size and the color changes. But they're in sync because this transition is making them be in sync. So now let's get a little bit more fancy. So now we've got, I want this letter to change with a rainbow. So it's like a rainbow letter, and I've got multiple rainbow colors, and I want it to change over multiple colors. So let's see how that works. So again, infinite transition because it's pulsing, it's changing through. And now I've got this color that I'm changing. Now I'm starting off at one value, and the end value is the last value of the rainbow. But my rainbow is an array. It's got all these colors in the array. And if I just had initial value, target value, it would just animate from the red to the purple and skip the in-between colors. So the way that I get it to go from red to orange, from orange to yellow, from yellow to green, to go through the rainbow is by the animation spec in this particular case is a keyframes one. So I'm saying here that at a particular interval, I just calculate what the interval is here. At a particular interval, this color needs to be at this interval. I'm incrementing the interval. So what I'm saying is at 0, it's red. At the next interval, it's orange. At the next interval, it's yellow. And so I'll get a smooth transition in between the colors. And then it's as easy as popping that color into my text, and then the rainbow effect will happen. So now this example of animation is something a little bit more complicated, and it doesn't actually use the underlying animation API. It's something that draws and where I track the position of these particles myself. So what I was trying to do here is I was trying to have a modifier that you can add to any view, and that it would, in the background, behind whatever's in the view, if you say it's visible, like if this goes from in progress to successful, then it would start drawing these animation particles. So let me show you how I built the confetti. So first of all, there's a simple class, like a Pojo, like any class. It's a confetto. Confetto is one confetti, and it knows where it is, and it's got a color. It's got some functions, one function to actually update the position. I'm not showing you the detail. You can look in the code in the repo. And it's got a function that it knows how to draw itself onto the canvas. So it gets a canvas in, and it can draw itself. And then there's a static method, which I'm also not showing, which will randomly put it randomly in a canvas in a shape somewhere. So that's just the basic, the single particle. Then I've got the confetti state, and it has a list of all of these single particles. It's got colors, and it's got a shape. It's got a way to say what shape is, if you want like circles or like rectangles. But the most important method of this class is this next one. And what the next function does is it will loop through each of the confetti in its list, and it will call this next method on each confetti. And the next method will figure out what the next position is on the screen for the confetti, which will actually make it move on the screen. And now this part, those two were just basic Kotlin classes. This part is the piece that's interesting. So in Kotlin, you can add a modifier to Composable, and I'm making an extension function on the modifier. And this extension function is called confetti. If you use this composed function, what it does is that every time you use the modifier, it gives you a composition where you can do compose things for that modifier wherever it's used. And so inside this composition here, I'm remembering, so this will put it inside the state so that the composer knows about it, a state of this confetti state. So the confetti state knows about all the sub-elements of the confetti. So that's how I remember the state of the confetti. And then this is a side effect. This is a launched effect. This is a coroutine that can run, and it gets the frame. So every single frame, it comes back. So if the frame updates, there's a callback here. And this is actually the draw loop now. This will be the tick that will make each of the confetti pieces move to the next place. So you would put the code in here that would make them move to the next spot. So that's just how they move, but you can't see them yet. And then a modifier has a draw behind method. So this draw behind method will draw behind whatever's inside the composable that this modifier is applied to. And this is where you would loop through each of those particles and call the draw function and make them appear on the canvas. Because at this point, you have a canvas and you can pass the canvas in to each of the particles. And how would you use it? So there's a box modifier, and all you would do is where normally you would add your modifiers, you would just add confetti, and it would add the confetti behind whatever you had. In this case, the box was black, it had a red hello world text, and then the confetti would happen to be behind it. Okay, so let's do a final demo. So over here you see the app without any animations. You can see it going through the screen. And now here you can see some of the animations. You can see, you should see, okay, so here's the transaction going through. There I've got some animated content. Here I've got my pie graph being filled in. There I've got my confetti showing a successful one. Here I've got, now there you can see a different confetti behind the loading because that's a modifier and I can add that modifier to any view I like. So we'll see as it loops through here, you can see this color changing over here. So this app has more animations in it than I'm showing because this talk is quite a limited time. So if you want to go explore the repo, you should be able to see some other examples of other animations applied to this app. And so now let's return just for a moment to these questions. When I started on this journey, I had these 4 questions. And maybe in your mind, you'd be able to answer them, but I'm going to answer them anyway. So the question, where is the draw loop? So in 2 places, but mainly if you're using the animation API, it's the composer that's actually knowing about the state and the state changes that happen, and it will recompose. So the draw loop is really the composer recomposing each of your composables. If you're doing it yourself, like in that modifier example, that's a special case, but normally it would be the composer that's doing the draw loop. The question, can I customize the animations? Well, we could see from the animation spec that there were lots of ways. You could have the spring, you could have those keyframes. There were lots of ways to customize the animations. Do I have to calculate the interim values? Well, no, because we've got these animate something as state methods, which would give you the interim values. And there are other lower level functions that you can use to get interim values. Unless you really want to, like in the modifier, with the modifier and the particles, I calculated the interim steps myself, but you don't have to worry about the interim values. There are enough library calls to calculate that for you. And then how do I trigger an animation? Well, if the state changes. So if you've got a flag that says something becomes visible, or you've got an on-click handler, you can make the state change. And when the state changes, you can trigger an animation to start. Or in the case of something like those repetitive, those cyclical animations, they kick off when the first time the composable is composed. So that would be another way to trigger the animation. And now just like a brief sort of look back at my impressions of this animation API. So the first thing that I noticed was that it was really declarative. I could just say I wanted a crossfade, or I could say I want to animate a color. I didn't have to go into lots of calculations, and it was quite easy to then feed these animations into existing composables, either by wrapping the composables or by sending the values that the animating values in as a state variable. So it was quite easy to add as well. So if I had an existing set of composables, I didn't need to think about animation from the beginning. I could quite easily add it afterwards as an add-on, so I could sprinkle it on into my app. The other thing that I noticed were that they were really good, those 4 first common cases that I mentioned in the API. Those are like the basic things that you want to do first off without being fancy. And those were really easy to add. So they had really good defaults. You didn't need to add a lot of parameters to set them up. You could almost literally just wrap your existing composables with those basic calls, and you could get something going. And then if you do needed to specialize, if you wanted to make the animations be quicker or slower or have a different characteristic, like more bouncy or less bouncy or completely non-linear, it was quite easy to add the animation spec, and the animation spec was consistent among all the different animation types. You modified them in the same way. So my takeaway is that it's easy for a developer to add an animation and just to try it out, right? Like even if it's not perfect, even if it's not as what a designer might do, you could quite easily do it. And then if you do need to modify it, it'll be easy to modify. So you can actually demonstrate in a live app, you can demonstrate to your designer an animation, and then they could assist you in making it and polishing the animations to be the absolutely perfect animation. And with that is the end of my talk. I want to thank everybody for this opportunity. I want to thank my code reviewers. You can see their names on screen. And there's the link to the Git repo and the QR code if you want to scan it. But I'll give the organizers the links to this as well. And questions. Do I have time for questions? I do.
Awesome, brilliant. Thank you, Maya. That was super informative. Really appreciate your contribution here. And is there any questions in the chat that you can take? Probably we've got a few minutes here. See. The video will be available. Yes, absolutely.
Video will be available. You can tweet me. I've got slide links and I've got the repo link, which I don't know if you want to share it in chat now.
Yeah. Put it in my chat with me. I'll put it on the.
Okay, I'm gonna stop my cam not stop my cam. Stop my share. Stop screen share, and move it back here so I can see if I can get the links for you. Let's see. I've got a link here. One link. Come link. Right, so here's the Git repo. That's the Git repo. Yeah. And then I have slides. And the slides actually have a lot of references because some of these animation techniques I've got a blog post on. It's got a reference to the docs or other blog posts I use to build up the animation. So the slides have got a big reference section in the end as well with lots of links for people to experiment with.
In the chat. Thank you so much. Brilliant. Thank you so much for that. Hope to see you again in another event, and we really appreciate your spending some time with us and bringing all that valuable expertise to the community and sharing that with the community. So have a good rest of the day. Have a good weekend, and thanks again. Thank you.
Cheers. Thanks.
Next, obviously. Okay, we are kind of before schedule here. Next is going to be lunch. So we're going to break for lunch. And we'll be back at 2 o'clock sharp for some more exciting talks. We've got really good speakers lined up for the afternoon session. So have a good lunch, and we'll see you after that. Thank you.
Hello,
Hello.
can you hear me right?
Yes, I can. Can you?
Yeah, cool.
Perfect.
Had some technical problems, sorted out now. Let's wait. I think we have a little more time. Yeah, we have 2 minutes. How are you today?
Fine, thank you.
Nice.
So, how is going the fest?
It's really busy actually here. It's quite nice. We're in person, but
I know. I really wanted to be there, but it was not so easy to travel with the current situation.
yeah. Where are you based?
Italy.
Ah, nice.
So I
Nice. I'm
wanted
from.
to
Yeah.
to make some quarantine upon coming, so I prefer to be here, and I'm here. So next time I hope to be in presence too.
Yeah, hopefully. Hopefully in the 2022 one, you can make it in person.
Yeah,
Let me share my slides really quick.
why not
Sorry.
later this year?
Yeah, exactly. Let me just go to the next slide. I think we should start. Cool. So, hello everyone. So we had our lunch break, and for the next session we're gonna have 3 sessions, and we're gonna have a coffee break. So the first talk is from too many clicks. Is from Carlo about animate your Flutter application, and I'm gonna hand it to you. I'm just gonna stop sharing. Let me just remove my thing. Stop sharing. That's your screen. Perfect. You take it from
Thank
here.
you.
Enjoy.
Thank you. So, first of all, thank you, Christos, for presenting me. I'm Carlo, based in Italy. I am a GD for Flutter and full-time Flutter engineer at Pivotal Technologies. Today, I want to talk to you about how to animate your Flutter application, because everyone's like animation inside our product, because the difference between two similar products anyway sometimes can be in the details. For example, a stunning application either for graphic or for animated effect can be the difference between an application that offers similar things, but it's more or less appealing to the user. So how we can add animation in our Flutter application? We have a lot of options when dealing with animation in Flutter. Let's see what are the most common. We can divide the animation in implicit animation, explicit animation. The difference is that in the implicit animation, the component more or less will animate by themselves without much effort. While in the explicit animation, we need to have more control. Then we can go deeper and having some low-level animation where we can control every pixel on the screen. It will not covered by this talk, but mostly I will talk about the implicit animation. But we have also other options like twin animation, physics-based animation, if we want to have item fall, for example, and so much more. If you go on flutter.dev and check the animation page, you will find this graph. This graph is a huge suggestion on which kind of animation you should use in your application based on what you want to obtain. Because you can have simple necessities or more complex one. Even have third-party framework like Rive that really enable you to make incredible animation. If you remember it, more or less like Macromedia Flash, but made in Flutter. It's an online tool. It's free to use if you keep your animation open source, and you can import directly in Flutter. and I have control over that by code. So what is your first choice between implicit or explicit? Because as I said, these two are the two common one that you can use. Let's see the difference. The implicit animation is immediate to use because basically it works immediately when you add the component. Most of the case, you don't have to do really anything to animate the component. It's easy because the effort to implement is really low. Just change some parameters. We will see that later during the talk. And is really fast because you don't have to write much of code. You just put your component, tell what it should do, and anyway, you will obtain a great effect on your application. Some sample of what we have as implicit animation. We have the animated container, the animated opacity, and the animated offset. I will use some of these during this talk to show you what can be done with the implicit animation. And then we have the explicit animation. The explicit animation gives you more control on what you do, can make your effects more complex than the implicit animation, because having more control means that you can change your animation more than the implicit one, and can be fine-tuned to your objective. Because if you use the implicit animation, you have to deal with some limit that it's inside the component. You don't have too much control, but in the explicit you can fine-tune every aspect of your animation. These enable you to be more flexible, because if I want my animation to be really specific to my app, I can just animate it the way I want. But it's more complex to do that. Some examples are the twin animation widget, the size transition, or the rotation transition. So let's imagine one application that we want to create. I want to create an animation that have a login page, and this login page should be animated. I want to animate an attempted login, so when the user push the button, I should tell the user with an animation that the attempt is in progress. Then I should animate this loading attempt either to a success or a failure state, and then I want to navigate to the next screen, and I want to navigate with an animation. Also, what we need to do is that said animation should be able to go to each state. Because, for example, after a failure, I want to go back to the base state before the attempt login, or from the success screen, I want to go to the next screen. And from the next screen, for example, after a logout, I should be able to go to the base state of the login animation. So when I am before trying to attempt the login. Let's start and let's see how we can do that. This is our screen. As you can see, we have a username and password. For this example, I don't really implement the login, but just a function that make more or less try a login for fake. When I click on the login button, I want the login button to animate to a spinning circle, and then I want to go to a success or a failure state. After that, I need to navigate either to the content of our application or back to the login screen. Let's see which option we have to do this. As I can say, you can go to flutter.dev and check the documentation. In the animation page, you will see a lot of suggestion on which widget you can use for every necessity. I suggest you to check this page, because also other than the widget catalog, you have also some code lab that can help you animate your application. What I will use is the animated container. I suggest you to check also the widget of the week video. You are seeing that in the screen right now. Basically, when you check the widget name and the widget of the week, you have a quick animation video on what it can do. For example, our animated containers, it's really easy to use because by changing its state, for example, changing the color, it just animates to the new state. It also have a lot of option to animate. You can change basically anything, shadow, gradient, color, size, and so on. But let's see how we can do that in our application. The first thing you need is to define a duration, because any animation, any implicit animation needs a duration. I defined a couple of animation. For example, you may have a fast duration that it's 500 milliseconds, or a slow one that it stay for 1 second. To exaggerate this example, you can even create a clock animated by just using a single animation during 12 hours to make the clock rotate 360 degrees. Also, the other parameter you need for your animation is the curve. You have on the Flutter.dev documentation all the curves already created by the Flutter team, and you can see their effect directly on the page. I choose these four just to show you how the animation curve works and how it will change your animation in case, for example, let's pick the first one, the elastic in out. As you can see in the translation square, it will bounce before going up and then will bounce out before setting in place. So I decided to use the animated container to make my spinner after the login attempt. What can I animate with the animated container? As I said, a lot of things: the sides, the color, the corners, the background, the elevation, the shape, the padding, margin, and alignment. And let's see how I created that animated button. First of all, I used an animated container. As I said, the first parameter I need to define is the duration. So I just used 1 second of duration, and I used a simple curve that smooth the movement in the initial phase and in the ending phase to have a more smooth movement instead of having a linear one. Then I created my effective widget UI. So what I did, and left some space for the next widget that should be inside that. What I did is, as you can see, as a margin, I'm changing it if it's loaded. I have no margin. Otherwise, I have a value. Same for the width and the height, that it's full screen when the login is already loaded. Otherwise, if it's still loading the login attempt, I have 100 of sides, either for height and width. This way, I will have a square. It will become a circle because of the box decoration afterward. And if it's not loading or loaded, it will be a simple button, 300 for width and 60 for height. Let's see how these will change. I made a try login function that basically it's just change the loading state, and then after 2 seconds it say that it's already loaded. These should more or less create the fake login. So let's see these in use. Basically, as I said, sorry, it's not loading. Let's try again. Okay. Basically, as you can see, the button will become big after the login attempt, and it will become red because I alternated in the code these suches. Basically, as you can see here, when the suches is true, you will have the color green. Otherwise, if the page is in the loaded state, so after our attempt, it will have the color red. Otherwise, it will be the classic green. So after the animation, let's go to our button content. Right now, the button is just a box that shrink to a circle, then expand to the whole screen. And it change color based on the suches. Let's add some content on that. For this, I used a stack. This stack is put where you saw the container before on the slide before. Basically, what I put in the button is the content that I have here. So I have the login button. On top, it will become a spinner and then an icon. How I did that? If you can see, I have some if here. Basically, in the stack, I have the circular progress indicator in the case we are loading, but not in the loaded state. If we are not loading or not loaded, we have the text with the login, and then we have the icon with the suches and with the suches or the X icon to show the current status of our login. As we can see in the animation, this was a little clunky because when the animation change, the object inside will change immediately. So we don't have a fluid animation between the state. How we can avoid this? I used the animated opacity. The animated opacity is another widget that uses implicit animation to change the opacity of the child based on the value and on the duration. What we need to do is just to say, with this status, we want to be this opacity and the duration of the change. Setting the state with the new animation, with the new state, with the new value, we will have the animation without doing anything. Let's see this in place. Right now, I had the loaded state, and I removed from the widget tree or inserted in this case. This caused the item to disappear or appear abruptly. But if we change this code with an animated opacity, basically we do the same, but the element is always there. But instead of disappearing, I change the opacity based on the state. So our spinner circle will be at opacity 1 if it's in the loading state but not loaded, and opacity 0 otherwise. I defined a different curve here. The interval is a curve that we can specify which curve. If we don't specify, it's the linear, that basically say start from half of the time I set. So if in this case I use 1 second, the animation will start at 0.5 second and will do the animation for the remaining part. And my child. So I changed that row with this widget. Let's see the result. Now the widget, as you can see, it's animating more smoothly because the element doesn't get all disappearing, appearing abruptly, but we have an animation. And I add this little graphic glitch, basically where the icon going down. But in this case, I wanted to leave that because I thought it were really cool to have this animation of the item disappearing. Now, for the last part, we should navigate. So we have our success screen, we have our failure screen, and then we need to navigate to the next screen in case of success, or to the previous screen in case of failure. To do that, we need a hero. If you know the hero animation on Android, you are already familiar with what the hero animation is. Basically, the hero animation is an animation between two different screens where you animate one thing on the first screen, transition it to a second screen. In Flutter, this is done with the hero widget. The hero widget, basically, you wrap your widget inside a hero, and you wrap the widget in the other screen in the same hero. The only thing you need to do is to define a tag that should be the same for both widgets. So when we wrap our item, we need to define the tag. Let's see here. The hero animation in Flutter say that you should use the most similar component in order to avoid the weird transition. But since I wanted to experiment with the limit of the framework, I used the hero animation on my app bar. Basically, what I wanted to obtain, it was to we are in the full screen button with the success icon, and I want to shrink that to the top to make the app bar on the next screen. Those are two completely different widgets in two completely different places of the tree, and I wanted to see how it will behave. So I wrapped my app bar on the second page with my hero animation, and I used the hero animation tag. The tag can be any screens. You don't need to be creative, just use the same string on one widget and on the other, and you will have the animation, like in this case. This is the button on the previous screen. So we have this positioned field that was the big green square, and I wrapped it with the hero and used the same tag. Then what I need to do is just to navigate to the main screen with the navigator push, for example, or we can use the named navigation or any means of navigating that we had. We should use the navigator to be sure we are in two different screens, because we can't have on the same route two hero animation, two hero widget with the same tag. Then I set my state to the previous state, because in case I go back, I want to revert to the old, to my old screen. So we navigate and set the state. Let's see the final result we have. Basically, when I tap now, I go to the success sample, and then as you can see, the navigation bar shrinked to the top. And for the error state, what we need to do? Basically nothing, because it was already working before. As you saw on the previous example, it was already shrinking down here. So if we have the error stage, we just don't do the navigation, and we get back to the screen. In case of success, we have our navigation and check out how the big rectangle become the bar. So this was all for my talk. Thank you for listening to me. If you have some question, please tell me. And as you can see here, you can see the link. If you are in an Italian Flutter developer, we have a community of Flutter developers there. Thank you.
Thank you very much. Let's see if we have any questions on
Sure.
the chat. Give me a second. We don't have something. I just have a quick question about the Flutter community. Do you like, how is it really big community in Italy with Flutter? Have you met recently, or has it been like a bit quiet because of COVID and all that for the last 2 years?
The community, it's online only, and we reached yesterday 1,000 members.
That's
only
amazing.
Italian developers, and it is in place since 2017. Basically, when I discovered the Flutter framework, I looked out for some community, and I found this one already created, and I joined that.
That's really good. That's a lot of members for a community, and
Yeah, it is.
that's amazing. Well done.
Thank you.
Thank you very much. Let me just share my screen. Yours is it, and yeah.
I have a hot reload. Saying hello.
Nice. Well, thank you very much for your talk. Enjoy your weekend, and yeah, also
Thank
I
you.
just wanted to mention that your talk is going to be uploaded later when the day has finished, so people can watch it later again if they have any questions and stuff. And I think you've shared your contact details. Let me just.
Yes, it's my Twitter handle. So if you look out for me, you have any question, please ask me your question on Twitter, and I will reply.
Perfect. Thank you very much.
Thank
We're gonna
you.
move
Bye bye.
into. Bye. Have a good afternoon. So, okay, cool. We are a little bit ahead of schedule, so we're gonna wait for our new speaker to join in a few minutes. We should be starting 1:30. Just bear with us, and yeah, we'll be starting at the 1:30. The next talk. Hello, how are you?
Hey, Christos, how are you?
Good, how are you? How's everything? So we're a little bit early. We're just gonna wait a few minutes and we can start. Where are you based?
I'm in Dublin, Ireland.
Nice. we actually have some people here from the organizer from the Dublin meetup here with us in London. Yeah.
And they've traveled over?
Yeah. First time in a while, they've said, which is makes sense, right? Yeah. It's quite busy actually today. It's nice to see people in person again here.
That's cool. And tell me, right, I have some slides, but I don't need to use them. Are people using slides or no?
So we are live currently, and it's up to you. This is how you want to do it. You can do it with slide, you can do it without. Yeah.
Cool.
It's completely up to you. I'm gonna just present you now. We are live already, and I think we can start. What time is it? Yeah. So hello everyone again. So our next speaker is David, and he's gonna talk to us about using device side processing to improve push notifications. And yeah, the floor is yours. And enjoy.
Thanks a lot, Christos. And I'm sorry, I would like to be in London today. It'd be nice to go to a conference in person again. It's been a couple of years. So I've only just logged in, so I'm just uploading a couple slides. Can folks see my slides?
I can share them now. Now they can see, yeah.
Perfect. Cool. Okay, cool. So what I'm going to talk about today is ultimately what we believe to be the future model that mobile apps will use to deliver really helpful and useful push notifications to their users. And I think, you know, we ultimately, so let me talk a little bit about my background first. So I was a computer engineer originally, and then myself and another guy set up a business called Ding, which is a mobile app that people can use to top up mobile phones anywhere in the world. And we have, you know, people top up their family members back home and themselves to get data and make phone calls, and we move about $500 million a year. So we have a very successful business, lots of user traction, you know, hundreds of thousands, if not millions of MAUs. And push notifications was a big part of that. We'd have special offers, and we were very early to do push notifications. We were very early to have an app in the App Store 10, even longer years ago. But out of that came an interest and obsession with push notifications. And I think we ultimately saw that, you know, and I became very interested because push notifications really have become what we call the primary interface, right? It's the first thing that people do when they, you know, when we all take our phones out of our pockets 60 times a day, the first thing we see is push notifications. And, you know, everything starts there. And we do think over a 5 to 10 year horizon, and everything we see with Apple and Google, and we know some folks at Google, not so much at Apple in terms of what they're doing, but everything we see says that more and more of the interface and the start of the interface will be on the lock screen, and that's obviously through the notification layer for iOS and Android apps. You know, there's lots of business and marketing reasons why push notifications help people come back into the app. We tend to think about it a little bit differently, and it's almost more that, you know, when you're thinking through your user flow, your screens, your journey for your users, be that, you know, first time or whatever they're using your mobile app for. Actually, a lot of times the user experience and journey starts with the push notification. And so if you're mapping out your screens and your flows, we always encourage people to think about actually the first screen is actually the lock screen with a notification in many cases, and especially with Android with the opt-in rates. And I guess we're still not into a kind of a runtime permission. It's a permission given in install. We do expect that that'll change, and we hear that will change over the coming while for most mobile app users. So I got very interested in push notifications in this business, Ding, that I mentioned, but I got really sort of frustrated and annoyed because we'd send out a push notification. We built all our own stack and hooked into GCM as it was then, and APNS for iOS. And we'd send one out, and, you know, half the people in the office wouldn't get it. And it's a kind of a common enough thing. It still happens today. So I got very interested in that. If we got it right, we could move $250,000 worth of e-commerce sales from that notification, as well as being something useful for our users to learn about some special offer that could help them deliver value to their to their loved ones abroad, which ultimately is the ding.com service. And so I got very interested in that, and myself and some guys, engineers I'd worked with before on some other stuff, we sort of said we'd go really deep on this, because we saw, you know, email, SMS, these ways to talk to and communicate to people, and this whole new thing of push notifications happening. And we ultimately got sort of super frustrated. And as we understood a little bit more about how the whole thing fits together and works, we really identified a bunch of problems. And you know, one is poor deliverability, right? You know, and there's lots and lots of reasons for that. And if anybody wants to talk about that further, I can talk for hours on that alone. But ultimately, you send a notification like an email, you know, using FCM or APNS or a vendor, which may sit in front of those for you and help you do token management and scale. The delivery rate is poor, right? And it differs in different regions. It differs for different handsets and OEM manufacturers, and we have relationships with a bunch of them. But ultimately, it is poor deliverability. And the rule of thumb is that the longer it goes from when somebody last opens your mobile app, the lower the delivery rate. You also have no control, right? So ultimately, you know, if you ask anybody how they feel about push notifications, they're like annoying is usually the first word, or, you know, hassling me, or stressful or anxious. And that's because there's little control over, you know, being user friendly and helpful to the user, which ultimately every app's got to be helpful or give the user something first before you have any kind of right to bombard people or annoy people with more marketing type stuff. Tricky to do personalization, right? You're synchronizing data from the device back to the cloud through your databases. How do you do that in real time at real scale? Lots of pain and problems there. And then how do you actually have some decent metrics on that? You'd be very surprised. As a large public company, we've spent some time with their CTO and some of their team, and they use 2 different vendors, and they have no idea how many notifications they send, let alone how many get delivered to users. They see the outcomes in terms of, you know, players and users in their app, but that's it. So that we kind of distilled back these high-level problems that we felt existed with notifications, and we wanted to then engineer a solution ultimately to solve that. This is push notifications and sort of the flow, right? So somebody installs your app, there's a push token generated, your device and Android will just stay with, you know, syncs that back to Firebase. That can take a little bit of time to happen. You bring that token back to your back end. You might use a vendor to manage all of this for you. The world's most popular vendors, probably OneSignal, super popular, and then you've got kind of more mid-market stuff. If you've larger apps that you're spending quite a little bit of money on, Braze and Airship are probably the leaders in that space. Then that token, ultimately, you or your vendor sends that from your back end with the message back to Firebase or APNS for iOS, or Firebase can route to APNS for free, and then deliver it back to the device. You bleed notifications and throughput here. These tokens change sometimes on OS updates, sometimes app updates. Sometimes it just happens. So you lose a bit there. You lose some delivery lag between Firebase. And we've done benchmark tests in the lab with the university projects and stuff. But ultimately, the biggest killer on deliverability is the device itself. So Android, and often not approved by Android or meeting the Android frameworks, you know, handset manufacturers and OEMs will do their own versions of Android. And ultimately, they all want long battery life, and what they'll do to that is, you know, the biggest use of the battery is screen and then connectivity, internet. And so what they'll do is they'll prevent apps doing things in the background, and they'll cut down that radio traffic, that internet traffic. And that means, you know, killing your app or force killing your app, shutting it down from doing anything in the background, which gets rid of all notifications, right? So that's what you'll see a lot of it. So it's a very, you know, it is surprising. And listen, I spent all my life you know, talking to mostly larger apps, but all sorts of mobile apps and engineers around notifications. This whole reliability thing is not a topic that's talked about much, certainly in kind of Europe and North America. It is something, and reliability is more in the consciousness of developers in Asia, and lots of reasons for that. I think emails probably less prevalent, notifications much more important in the key Asian markets, but also there's far more lower end handsets that have even more of these reliability issues. So I think where I skip through this, ultimately the solution and the engineering solution that, like, listen, we've been on a 6-year journey in OpenBack, very, you know, myself and a bunch of engineers, very focused on solving these big problems. But ultimately, we're super we want to sort of share with the world how we've solved these things, because we do think that this is the kind of future, and the more people that think about this in this way. So ultimately what we're all about is shifting the control of what notifications an app uses and delivers out to the device itself, right? So there's a kind of mobile edge computing, very buzzwordy. Really what it's saying is the app doing more of the compute, more of the lifting, you know, within its allowed frameworks, you know, on device, often in the background. So kind of using different background tasks and services on Android and background refresh on iOS. In general, this shift to sort of device side is something that's sort of happening, and it is happening slowly. Apple are driving a lot, iOS driving a lot from a privacy perspective, because doing more on device means you need to collect less user data off the device to do interesting things. And I think what we've seen, and we have some relationships with some of the Android folks on the product side in privacy, you know, Android also have this sort of shared view. And if you really want to do personalization and be super helpful for your users of your app, you're going to personalize more. But to do that in a privacy first world, which is super important, more has to happen on device. There's a bunch of other advantages as well, right? Because you're able to use that data in real time, so you're not sort of synchronizing multiple backend platforms and systems. You know, you're doing much more on device. So you can, you know, be in true real time for the user, and then you're sort of reducing cloud costs and complexity, particularly for apps at significant scale. I mean, we have a couple of apps who use our platform, vendor platform. There's a couple of 100 million devices, and they were able to save a whole bunch of, you know, cloud compute ultimately to deliver these really personalized notifications, personalized content, and what have you. So I think it's probably everyone here is familiar. There is ultimately two ways to deliver a notification to a user of your app. I've talked mostly so far about a remote push notification or a Firebase push notification, where this token you've collected to your backend or a vendor, or just your Firebase SDKs, send that back, and the message hopefully comes out the other end. Usually it does. The other way that any app can do is a local notification. I'm sure most people listening to this are fully aware of this, but just to sort of cover it off. And this is where your app itself can deliver a notification or schedule a notification to be delivered at some point in time. You can schedule these notifications while your app is operating in the background, or, you know, when it's been opened, that local notification, you know, can be scheduled as well. And ultimately, what we've done at OpenBank is built out a hybrid platform that actually always delivers to the user using a local notification, but replicates all of that sort of Firebase cloud side capabilities, things like rich notifications, interactive buttons, you know, personalization of content, multi-language support, like all these endless features, but always delivering it device side for local using a local notification, which looks identical to the user, same user permission asked for, you know, you granted once at either runtime or install, depending. And so that's where we've done this, and we've worked with a whole bunch of different mobile apps to prove this out over the last few years, and it's been incredibly difficult. I think probably the parts that are hard is to reliably synchronize all the data from device side on device with the backend to give that seamless experience for the app or the community manager, the marketing manager, but then also then for the engineers to be able to set it up in a very simple way, not have to worry about it all. But ultimately, this device side approach for some of your apps, if you have simple messaging use cases, local notifications may be a great solution for you to be able to simplify and deliver those couple of great edge cases, or not even edge cases, but, you know, use cases or messaging cases. I think we, you know, doing device side notifications, you can radically sort of increase the reliability and deliverability. So if you have apps that, you know, the notification is a core part of the service, you know, and getting that notification from the user is a core part of the promise of that mobile app, the functionality of your app. You do want to think about this. Doing device side, really, for Android, what's happening here is a bunch of very elegant services to check in the background every so often, being highly mindful of things like Android vitals, right? You can't run a constant service. You want to schedule, we do lots of different techniques. Reach out afterwards if you want to talk more about that, but like it's stuff like, scheduling different alarms, using different activities that the device goes under, all just every so often to be able to check and see for this user, should this notification be delivered? And we talk in a different, and it's a bit more for the sales presentation or our brochure website, but we talk about signals. So stuff like somebody just unlocked their device, now's a good time. Can we do some on-device learning to predict that this person normally uses the app in this pattern, and it's an ML predicted pattern, so they, based on other contextual factors and signals, then pop up a notification, or are they awake today, right? So we're not delivering it in the middle of the night, but also stuff like taking notifications away again, or not delivering them at a bad moment for somebody, right? So it is always, balancing that, delivering at a good moment versus delivering at a bad moment, right? And optimizing those are sort of two sides of the same scale. But by doing device side, you can have a massive impact on deliverability or reliability. So this is some sample data here. So if we look at, say, Samsung, conventional FCM push, 24% delivery rate. This is on a sample of 1.6 million active devices with a large group in Asia that we work with. And by adding the sort of device side capability on top of that, you're jumping it up to about 60% deliverability rate. I'd say it's a high potential, people listening to this today, that even seeing that your delivery rate is only 24% maybe a shock, and is often a shock to many folks, especially then you look at some of the other lower end devices. And I should say these are mostly sort of lower end devices in this case. So I think the other piece, and this is something that we're probably seeing the biggest trend of activity on, is around data privacy, particularly, and we're sort of seeing the first adopters of this really being from the kids, either games or education, and sometimes it's a blurry line. So for those app categories where, listen, quite frankly, the GDPR and GDPR-K are somewhat, there's high level precepts to follow, but nothing specific. But if you look in the US, COPPA, which is the Child Online Privacy Protection Act, is absolutely explicit that the push token is considered personal data and you cannot collect it without parental consent. But by doing things device side, you don't need to collect that push token to be able to deliver the notifications. The app itself holds the rules and the rule engine to deliver the message. So we're probably seeing big movements from both iOS and Android around this. I mean, Android are doing some super interesting stuff around sort of private compute clouds, where the user and that app on that device, on device, is that user data, but actually Android will provision a private cloud just for that user, encrypted end-to-end, just for that user on the cloud, to give the advantages of cloud, but still sort of locked down just to that user's data, which is sort of a super interesting trend, and almost builds on, it's probably a further, sort of a longer range trend, and sort of builds on, the things today that are happening around device side. But we see app category, kids, as I mentioned, but also healthcare. There's a lot of stuff about legislation around the world around patient data and not sharing patient data. And you'll all have personally seen the sort of COVID tracker apps that are using anonymized data device side to pick up anonymized tokens of people around you, and then alert you if you've been a close contact of somebody. But all of this really is sort of thinking about device side and rethinking how the cloud works with the device, and how does synchronization happen between the app on your device and using the compute power that's on the device with coordinating in the cloud, right? Because ultimately, if you're a multiplayer game, right, there's so much stuff is happening in the cloud, but there's still lots of thinking to be done around, well, what makes sense to happen on the device and what makes sense to happen in the cloud. And certainly we have a very strong view that it is a hybrid of the two. And I think one of my colleagues talks a lot about the shifting trends over the years, where compute was centralized into kind of large mainframe computers, then it sort of migrated out to sort of personal devices and servers, and then we've sort of seen this huge sort of shift to cloud. And what we think, we're sort of seeing now the start of a shift back to being a hybrid between device side and cloud. So if we give you a just a sort of a high level. So conventional push notification, this push token gets collected, back in server, back to Firebase, an APNS, and then back to the app, delivered to the app, sort of like an email, right? And there's tons of vendor platforms to help you with scale here. I think where we think about it, and listen, this is branded Openback, but there's no reason you can't build this yourselves. Talk to us. We'd be delighted to help you. You know, we really believe strongly that this is the future, and we talk very openly to anybody about the challenges we've overcome to create a vendor platform. But really, you know, at the end of the day, we're very firm in the view that sort of a rising tide lifts all boats, and so we're very happy to share how we do what we do and why. But ultimately, what we're doing is shifting the rules, the personalization, the content, everything out to the app itself, which becomes the controller of when that user gets the notification, get it to them reliably, or when they don't get it, and do cool stuff too, of like take it away again, update the content dynamically. There's endless cool stuff that can be done. But ultimately, that's this shift in architecture that we see, and we're very focused on notifications, given what I said sort of at the start of the talk around how notifications, we just think for apps that are lucky enough to stay on our phones and be on our phones, you know, the use of contextual and personal data on device only will shape those future, those future user experiences and where they start. I think I've probably touched on a bunch of this. I think fundamentally, you know, for folks building their own, and what we tend to see is the really large apps of the world build their own. And we actually, our SDK and our solutions in use by 2 of the top 10 apps in the world. We're not allowed to name them. One of them's a very big social network, and one of them's a very big sharing app, more so in Asia. But you can build this stuff yourselves, right? Ultimately, local notifications, you can schedule it in advance. You can cancel it in the background. You can clear badge counts. It's pretty basic functionality, but works super reliably. The bit that takes a bit of time, and it's more time to build than it is complexity, is to synchronize, you know, if you need dashboards or back-end control of what happens later on device, right? And there's a whole bunch of architecture and infrastructure to build out for that. That's the hard parts of it. So if your message cases are complex, you probably do want dashboards for your live ops content teams. You want the ability to track metrics and do A/B testing and evolve over time. And that's probably where you start to drift into, you know, hang on, does it make sense to talk to a vendor to help us with parts of this? But, you know, we're always happy to help folks about this kind of big idea that ultimately notifications should be controlled device side. And the other thing we're seeing, and we're working with some folks on at the moment, is that we expect to see more and more gameplay being extended to the lock screen. And we do find that gaming apps are kind of earlier adopters of this sort of technology. A lot of times being callous, and, you know, it is down to gaming often being such a low margin business, and every user counts, and every little bit of incremental play that can be gained by the user matters to the business and improving lifetime value and things. So they tend to get this stuff very quickly, and we work with a bunch of interesting gaming apps, but we're working on some cool stuff now where actually the gameplay gets extended to the lock screen, right? So if somebody's out and about, they get a notification, and and somebody's attacking them in a game, and they get the option to turn on their shield just by clicking the notification. They're not actually even going into the app itself. The app is handling that in the background. And we expect to see more and more of this. And I mean, we all see this in our daily lives already. Whether we use it or not is a different question. But, you know, stuff like replying to a WhatsApp and a DM straight from the lock screen. And we just expect more and more of those user interactions, behaviors that make sense to happen, through the lock screen. But to deliver those great experiences and that contextual experience, it does mean more has to happen on the device and on your app on the device. Yeah, so I've done a bit of a whistle-stop tour through, I guess, the device side, and how we specifically, and it is really what we spend all our time thinking about, is how does device-side computing improve push notifications for lots of apps, and ultimately those kind of 4 pillars of advantage by doing more device-side when it comes to notification of improved reliability. 1, 2, control the moment of delivery, so you don't piss off users, but you deliver something more helpful to them at a more helpful moment, and that moment isn't just time, it's lots of other contextual stuff like predicting if they're at home or at work without ever tracking their location, or they just plug their headphones in, whatever. Third is on data privacy and being able to personalize and use that data without having to collect it. And then fourth is sometimes it's important, especially for the really scale large apps hitting tens, hundreds of millions of installs, but on the cost side and having more compute happening on the device. And so I'm David Shackleton, and I guess the company is open back, but if anybody's interested in digging in further or learning more, please reach out to me, and love to continue the conversation. And thanks for your time on a Saturday afternoon. I appreciate it.
Thank you very much. So do you have your Twitter handle or anything?
Yeah, let me.
Where basically, where is best for people to find you? Where is best?
Yeah, I mean, my email is just david@openback.com, or my Twitter handle is @dshackleton. I don't know. Can I put it into a shared chat?
Yeah, you can drop it on the or if you drop it on the private, I can drop it on the server.
Yeah, perfect. Yeah, I'll put
whatever word. Nice, thank you very much. Let's see if we have any questions from the audience. I don't see something. I have a question. I don't know. It's not really technical. It's more like something that I've observed, and I don't know if you've seen it in the industry lately. Yeah. I've heard quite a lot of people saying that. Actually, we have a question. Is it reliable for PWA to deliver a device notification?
So I guess what I'm talking about, and being very honest, what we spend all our time thinking about is Android and iOS apps as opposed to PWA. And actually for a progressive web app, you're kind of because ultimately the interface is through the web browser. You're limited in what you can do, right? Because it's much harder because of the layers of abstraction to use the device capability to improve it. So it's not something I'm aware of. I don't have the expertise on it, to be honest.
Sorry, we did another conference back in May. I think it was. There was talk about the APIs that Android is creating for the PWAs that they will be able to use. I'm not sure if one of those APIs was for notification. It was for cameras and things like that, but I'm not sure if there was.
Yeah, and I guess it's more kind of what we would distinguish between a web push, right?
Yeah.
Which would be PWA or go to any pushy website, and then what we're talking about is kind of mobile push.
The question I was going to ask, I've heard from quite a lot of people that they have turned off a lot of notifications on their phones, and I don't know if that's something that because of the pandemic and they've had it next to them all the time. And I don't know if it's something that you've seen in the industry. And
so we do you know what's interesting? If we look across lots of different apps and different app categories, we tend to see about 45-50% opt-in for iOS and about 85 to 95 for Android. And the difference between the two really is runtime versus install when the permission is granted. And obviously, Android is shifting more to an iOS-like model. So we haven't seen too much change during the pandemic and things. I think it is interesting. We're watching very closely, some of the new stuff on the iOS side around notification summaries and being able to control notifications with the OS to deliver in batches. And we're seeing that actually not that much uptake by users, but it is interesting to watch. And it is an iteration of the interface and the adoption of it. I think ultimately, listen, if you want to reach out, I think I've written a blog post about this, but there is ultimately you need to show your user that you're going to add value for them to trust you and allow you to do notifications. And earning that trust, as ever with users, is the most important thing. And it's balancing, giving them something useful that's helpful, that extends the functionality or the reason they have your app, with okay, you do want them to use your app more often. You want to push them down a monetization funnel is often the case, like it or not, often for engineers. But it is that trade-off. I mean, stuff like, certainly if it's in runtime with iOS, you prompt after they've seen some value, right? And tell them why you're looking for that prompt. The other things we see that is helpful is within the interface of the app itself, allow people to use kind of categories or topics, but categories, I guess is the name of the functionality for Android. So they can opt in and out of different types of notification, right? Because you're limiting the chance that somebody just blocks all. Ultimately, that's the easy way to do it at an OS level and whatever. But providing that sort of granularity to the user almost is helpful, and it also shows your intent to be less annoying and more helpful, right? Which is ultimately the big user goal.
Yeah, I think that's really important. That's really nice. Thank you. Thank you very much. Again, your talk is going to be uploaded later when everything's finished, and you're going to be able to watch it again. Thank you very much for giving up your Saturday. Yeah, and have a great weekend.
I definitely won't watch myself back. I'm one of those people who can't stand it. Somebody else might.
Great. Bye.
care.
We're going to move to the next speaker. Okay, so the next speaker, we've got Carlos. Let me just hello, how are you today?
Hello, I'm fine. How's everyone?
Yeah, good, I think. Where are you based?
I'm from Portugal.
Oh, nice. Are you
We're in the same time zone.
Yeah, are you in Lisbon or Porto?
No, I'm in between both. I'm in Coimbra.
Okay.
It's a university city that it's in the middle between Lisbon and Porto.
Oh, really nice. Really pretty over
I
there.
can visit both cities quite easy.
That's cool. Nice. So like quite close to Sintra. Like Sintra is to the north, right?
Yeah, Sintra it's to the south, and
Is it? Okay.
Coimbra it's to the north.
Okay, perfect. Let me just share my slides. So, what time it is? Yeah, we can start, I think. So, Carlos is going to talk to us about, well, it just works, and it's running.
Hopefully.
Yeah, running Compose on Android, desktop and web, along with KMP, which I had to ask what KMP was because I didn't know. But yeah, thank you. If you're ready, do you have slides? Do you want to share your screen? And
yes.
I know. And the floor is yours whenever you're ready. Let me share your screen. Perfect. Nice. The floor is yours. Enjoy.
Thank you. So, hello everyone. Let me start by saying thank you to everyone from the DevFest team for putting together this great event. I've been up since early morning on a Saturday, so I've really been enjoying the event. There are a lot of tracks, a lot of talks worth watching, and of course, also I want to thank you that you are in the other side of the screen. I hope everyone is safe and secure. So, my name is Carlos Mota. You can find me on Twitter at @cfonsmota. I'm an Android GD. I'm the founder of GDG Coimbra Content Nights. I've been writing at Rio Under League, and I love to travel, photography, and running. So I hope I could be on the next event with you in person without being with a screen away, let's say. I've created a couple of resources for this talk. You can find these slides on my speaker deck. I've also created a sample app and a template that I'm going to tell you at the end that you can find on my GitHub. And I've been trying to also post videos online to try to explain better the concepts of Compose or with multi-platform. So feel free to subscribe my channel on this link. So let's start with a brief history of time. I would say that at one moment or the other, you face something like this. You have your group chat with your friends, and you just had an idea, and you're just going to type, "Oh, everyone, I've just got an idea." And because these are your tech friends, someone is going to say, "Oh, great, are you going to do it natively?" And then there's going to be that other person that's going to say, "Natively, you can use Xamarin, and instead of Android only, you get Android and iOS." And Flutter is becoming quite popular, so someone is going to say, "For that, should use Flutter. It has better performance." And if I'm on that link, I'm going to advise you, of course, to use Kotlin multi-platform by saying that, yeah, Flutter uses Dart. You're already familiar with Kotlin. You should try Kotlin multi-platform. And then your React Native friends are going to say, I've been using React Native and it's great. And then more 12 people are going to give different opinions. And basically, this is a lot of what happens when you want to develop an application nowadays. So let's start with the first question: how to develop an application. So it's not as easy to decide how you're going to do it, because this depends on a lot of things. First, it's your team background and size. Can you allocate people to develop for iOS and for Android and for the web and desktop? Also, what's the background of the people that are working with you? Are they coming from the web? They already know how to develop for Android or iOS? Can you have people specific working for Android and iOS, or you need to have someone that's going to develop both? Also, what's the project that you're going to develop? It's going to be an MVP. You're going to develop a couple of months, 1 to 2 years, or are you going to spend the next 5 to 10 years working on that project? There is also, of course, constraints that are more business related. For instance, do you have a budget that you can use to hire more people? Can you allocate more? How's the schedule? Do you have time to learn new things or to test new things before, or are you already behind schedule? All of these things need to be think before starting a new project and to select one of these frameworks. Of course, a couple of them have some common disadvantages. For instance, on all of these, you're framework dependent, meaning that what you're going to develop are going to be using widgets, and if there is some update, you might not see it immediately. I'm going to tell you a story from a couple of years ago. I developed an application for iOS, and Android, and there was a huge redesign on iOS, and I was using Xamarin at the time. And my application, when people updated to iOS, to the new OS version, they were still seeing on my app the old components. Because, well, when you develop an application on one of these frameworks, you're using widgets. So I needed to wait, I think it was 4 or 6 months for an update for these widgets. I needed to recompile my app again to submit it to the store. The users needed to update it. And only after that time, I was able to have the new application with the new layouts, with everything. Of course, if I'm running this application on an older device, you're going to see the new UI. So it's always a bit strange. It seems that things don't match. And for instance, when you talk about iOS, when there is an OS update, typically 80% of the users update it on the upcoming days. I can tell you that that application had a couple thousand of users, and I lost 60% of my users during this time period. Sometimes there are missing features on this platform, especially if they only exist on one platform and not the other, and you end up needing to implement them yourself. You've got a slower performance. I know that this is always arguable, but you have a layer on between, so the performance is not going to be the same. And you're committing to one framework. Imagine that you're going to develop a project for the next 5 or 10 years. What's going to happen to that framework for the next 5-10 years? The framework will still exist. If there is no more support to that framework, are you going to develop your application and the framework? Are you going to rewrite the whole application? These are a lot of things that you need to think before selecting one of these solutions. Of course, I'm here to advocate a great approach, and I'm just going to give you a spoiler. How to develop an application? Kotlin. So Kotlin multi-platform, it's incredible. I've been using it for the past 3 years on my side projects, and for 1 year now on projects that are on production, and we're really happy with this result. First, it's Kotlin. You can take advantage of all the language features that Kotlin gives you. Also, it has low risk. When we started migrating our project to multi-platform, we start working on a new feature that was built on multi-platform. We iterated over that feature and tried to find what best worked for us. So after that feature, we started to rewrite parts of our app, especially when there was 1 or 2 bugs related with it. And from that point on, we keep adding new things to multi-platform. And now we've got an app built only on multi-platform. This gives you consistency across multiple platforms, since you're going to share the same stack. It also means that if you're going to add a bug, you're going to add a bug on all platforms. But if we see things positive, this means that when you fix a bug, you fix on all of these platforms. And you've got a really strong community support. I've asked questions on the Kotlin Lang Slack countless times, and in a couple of hours, I always got an answer that I was looking for, and it allowed me to continue my development. So Kotlin multi-platform, it's incredible. Kotlin multi-platform means that you want to share your business logic. It doesn't work with UI. It's focused only on business logic. For instance, imagine that you want to build an application for Android, iOS, web, and desktop. Typically, what you're going to do is to develop your view, and then your presentation, your model, your parser, your network layer. And then you're going to do the exact same thing on all of these platforms. Okay? But if we look at the business logic, this business logic, it's going to be quite similar. For instance, on Android, you might use retrofit. On iOS, you're going to use Alarmifier. The logic itself, it's almost going to be the same. Nothing changes. The only thing that's going to change is the view and the UI that you're going to use to develop your applications. So the goal of multi-platform is just to merge all of this and have a single business logic that you can share across all of these platforms. Let's see an example. Imagine that you want to share, imagine that you have something that's platform specific. Imagine that you want to show a text message that says, hello Android, hello iOS, hello web, and hello desktop. Because this might happen, you might need to work with platform specific logic. So what you are going to do is you're going to use an expect keyword to say that, okay, I expect someone that's going to define what name is. And this is going to be done on your shared model on a specific folder called common main. This common main contains all your business logic that's not platform specific. Okay, so you expect someone to define what name is. And then you're targeting Android, desktop, and JS. You're going to go from common main to Android main. And you're going to say, actually, what name is on Android is Android. So you're going to use the keyword actual to define what name is for the Android platform. And then you're going to do the same thing for desktop and GS. So as you can see here, actually on the desktop main, you're going to mean desktop. Actually on web, it's going to mean web. When you're going to compile your project, you're going to be able to create your libraries for Android, for JVM, for the frameworks for iOS, the GS files for GS. You're going to build libraries for all of these platforms. And with this platform-specific logic with common and actual, you have the guarantee that you're only going to have Android code on Android, iOS code on iOS, and GS code on the web. So how to develop application, Kotlin multi-platform, and how to develop the UI, Compose. Although the goal of multi-platform is to share your business logic, you can now use Compose at the multi-platform level. Let's dive in a bit with Compose as we start. So if you look at the Compose website, you're going to read a lot of excellent keywords. You're going to see that it's intuitive. You're going to write less code. It's really fastens your app development. It's really powerful. It's a new UI paradigm. And this is great. And I've been using Compose since early January last year. And it really fastened our app development. But there's more to Compose that we might think, that we often think. For instance, this was the first tweet where I thought about this, because Jake Wharton was saying that he was able to create a project where he was using Compose with iOS. And how does this mean? How can you run Compose on iOS, on desktop, etc.? Let's look first at the Compose libraries. If you go to Jetpack Compose, you're going to see that it's composed by the compiler, the runtime, the UI, foundation, material, and animation. And we can grab them all together and create what we can call a Compose UI toolkit, that this is Android specific, the Compose UI, foundation, material, and animation. And then we have the Compose compiler and the runtime that you can use on other platforms. Let's dive in a bit with the compiler. The compiler is written in Kotlin, and basically what it does is transform the composable functions into UI. That composable, it's an annotation that you're going to use on your project. when you have a function that's going to represent the UI itself. So this doesn't use annotation processor. So this guarantees that when you want to build your applications, it's fasten to compile your app, and it doesn't have to rely on annotation processor for that. It's also open source, so feel free to go through this link and see how the compiler really works underneath. My advice is it's some heavy reading, so be extremely careful. On top of the compiler, you have the compose runtime that is platform agnostic. It doesn't know what a UI is or what Android is. It's platform agnostic. It's basically a tree management solution that the compiler uses to know what should call. On top of this, you've got the Compose UI toolkit with all the libraries that will allow you to create your applications. So you've got animation to create those amazing animations almost outside of the box. You've got the material that allows you to have your design system on your app, the foundation that contains the column, text, image, all of these functions that will allow you to create your apps, and the Compose UI that allows you, for instance, to listen to what the user is writing on the phone and put this data on the text field. And with this, you've got Compose or the runtime and the compiler, and you've got Compose for Android, desktop, Raspberry Pi, web, console. And in the last few weeks, we've been seeing a lot of JetBrains trying to push or to show a bit of Compose for iOS. So the next weeks are going to be really, really enthusiastic. So also worth mentioning that Compose multi-platform is stable. So the 1.0 version is now live and you can use it. But let's get back to our application. So I've developed an application for Android first, and then with this UI code built with Compose and my shared model logic built with Kotlin multi-platform, I was able to run it on multiple platforms. So on Android, this is the code for Android. And basically, I'm accessing the Unsplash API to get the latest images. I'm now going to search for Portugal, so you can see the text input here, and is retrieving images from Portugal. This is a really simple application with two screens. You can navigate on the bottom using the navigation bar from one to the other. Then with this, what I did was, okay, let me see if I can run this on my watch. And basically, I moved to Wear OS, and I was able to basically using a couple of components and using a different scaffold, run the same app on my watch. Then I moved to desktop and try to reuse the same thing. Of course, I needed to use a couple of libraries here, but I was reusing the code that I had for the UI. It's the same code that I'm going to reuse here on the desktop. And you can see that it's a desktop because I can resize this window. And then I was still missing a platform, so the next one, it's the web. The web is a bit more tricky, on my opinion, because you cannot reuse as fast as you can to reuse for the desktop. A couple of libraries are available for the web, and web still uses some DOM elements like the flags for attributes, the divs. You still need to use them, and you can just call column and have your app ready for the web. You still need to do some extra work. So I bet that all of you dreamers out there are asking is, okay, imagine that I've just created my Android application. How quickly can I have a desktop and web apps ready? So my solution at this moment is do it with Kotlin multi-platform to share your business logic and use Compose to share your native UI. So if you want to use the multi-platform part to share your business logic, you can target a lot of devices. You can target macOS, iOS, WatchOS, GS, Windows, Android, etc. You've got to migrate your application to multi-platform. This means that, for instance, if you're using retrofit on Android, you need to migrate to use Ktor. You need to use a multi-platform library for this. And there are a lot of good multi-platform libraries that allow you to achieve the same things that you're already doing on Android. For instance, you've got the Kotlin X routine, serialization, datetime, atomic foo. You've got the Ktor for network. For storage, you've got the SQLite. And there are almost weekly, you've seen new libraries that are going to help you develop faster for multi-platform. So how to start? Quite easy. install the KMM plugin on Android Studio, create a new KMM application. When you create a new KMM application, and KMM means Kotlin Multi-Platform Mobile, you will need to duplicate a couple of folders because it's going to create you just for Android and iOS, but you can easily configure everything for the desktop and for the web. So this is your structure of your project. You've got Android app, desktop app, and web app. For instance, on Android app, you're going to have your activities, your fragments, everything that you need. And then on shared, you've got the common logic. You have your network requests, your database logic, all of this. So if you open now shared, you're going to have, for instance, Android main, common main, iOS main if you're targeting for iOS, or if you're targeting for desktop and GS, as we're doing it right now, you're going to have your desktop main and GS main. The common code belongs on this common main folder, so this is where your expect clauses are. And on Android main, desktop main, and GS name, you're going to have your platform-specific code. So you've got to have your engines. For instance, imagine that you want to use the shared preference on Android, so on iOS it's NES user defaults. All of this logic that it's platform-specific is on Android, desktop, GS, iOS main folders. If you open the build.gradle file, when you want to add a new platform, you basically have Android and iOS here. If you want to add, for instance, desktop, you just need to call GVM and give it the desktop name. If you want to target for the web, you just call GS and you define a couple of parameters, and that's it. After this, you will need to migrate all of your libraries to multi-platform. You cannot have Java code here, for instance. So basically, imagine that you want to move from Retrofit to Ktor. You need to implement the Ktor library. In this case, Ktor requires you to define the implementations for Android and the GS. Of course, it's not only implement this, you need to migrate all the API calls also to Ktor. To migrate the databases, you need to migrate them to SQLite and to use serialization, for instance, to deserialize the responses that you get from the network. You need to use the serialization JSON API, the library. Of course, once again, after all of this, you need to migrate API calls. This may take you some time, especially it depends on the complexity of your app. So you don't need to refactor the entire project. I know that this is going to be really time consuming, and it's going to add a couple of issues. Of course, every time you refactor, there is the chance that you might add 1 or 2 issues. So you don't need to refactor everything. Once again, one of the cool advantages of multi-platform is that you can decide what you want to share. You can decide what makes sense from your application. This is a couple of examples from a talk from 2019, where a couple of applications that were already in production at that time used multi-platform differently. So Space is full Kotlin multi-platform, KMP. Cash App uses the business logic that is shared. Index Maps also shares the wrappers for C++ libraries. PlanGrid shares the synchronization logic, management offline data. So different applications share what makes sense for them. So how to decide what you want to share? Start small. This is going to be something different for both teams. So see what makes sense on your use cases, on your application. You're going to develop a new feature. It's a good idea to do it on multi-platform. If you're going to make a lot of changes on a specific feature because there are bugs, perhaps it's a good idea to move it to multi-platform. You're going to add tests. Perhaps you can do those tests on multi-platform. What challenges are you going to find along the way? Well, the first one that you're going to find is that not all libraries are available on Kotlin multi-platform. And even those that exist, they might not support all the targets. It's often common that you have a library for Android, iOS, and desktop, and you don't have it for the web. Also, the library when is built is compatible with a specific Kotlin version. Kotlin compiler keeps updating. Sometimes you're going to use a library that's not compatible with the latest version of the Kotlin compiler, so you need to downgrade the compiler for some time. The initial project setup requires some time to have everything right. For the web, sometimes you need to use the annotation GS name to guarantee that the function that you're going to call, it's that one and not one with a method a bit strange. For iOS, you need to use export. There are some difficult configuration on the beginning, and that's why I've created a template that you can use called Alicers. You're going to see this at the end. Especially when we talk about the web, the generated library, it might need to lose some weight. For instance, if you're going to create a simple application just using Tor for networking, and when you compile it for the web, it can gain some megabytes, which for the web it's really difficult. You may use techniques like Minify or gzip to reduce this file, but this is some extra work that you need to have. Now moving to Compose. So how to start developing for Compose? If you're developing for the first time, my advice is to start first with an Android application. Once you're familiar with, you can now move to a shared model and then share it with the desktop. You can create an application quite simple. There is a template that Android Studio already provides, and you can just start an application with it. And once you're familiar with Compose, as you have that shared model, you just need to create a new shared model and call it shared UI, where you're going to develop your application UI that's going to be shared with Android, desktop, and the web. Talking about sharing this code, you'll need to do a bit of custom multi-platform for that. Mainly because, well, different platforms mean different behavior. For instance, if you want to resize the window on desktop and have different behaviors, this is desktop specific, and you need to work with this logic. Also, you have different input types. So on the Android, for instance, you're going to use mostly your fingers to scroll and to navigate. On desktop, you have a trackpad, you have a mouse, you have different ways to interact with your screens. So there is a Compose version for Android. It's called Android X Compose. And then there is the JetBrains version of Compose called Org JetBrains Compose. If you try to use both of them, you're going to have a couple of issues. Namely, you're going to have duplicate classes issues. So the solution here is that you need to use the JetBrains Compose versions. So instead of using Android, you're going to need to use the plugin Org's JetBrains Compose. Basically, what's going to do this plugin is, as you're compiling your application, it's going to see if it should use one package or the other. This is done automatically by the compiler. Once again, the big question here, do I need to refire the entire project? No. So Compose, it's interoperable with XML. You can have both things on your app. You can have screens made with Compose. You can have screens made with XML. What challenge are you going to find along the way? Well, once again, the initial setup can be a bit challenging. Because of this, you need to use the Compose plugin on one thing. You need to use the JetBrains Compose on the others. And for instance, if you miss the initial configuration, your project can take several minutes to compile. This happened to me quite a few times, that I was importing too many libraries that I didn't need, and the project ended up wasting 5-7 minutes compiling without needing. Once again, some libraries depend on the Compose version. This already exists on Android. So imagine that you're now targeting desktop and the web. Well, you have more dependencies that you need to take care about. And once again, not all features are available for desktop and for web. There is no direct support for internationalizations, for fonts, for resources. Live data and view models that are Android specific, you can have them on desktop, but only with third-party libraries. And of course, this is my opinion, but for me, web is still on its initial stages. Not all Compose functions are ported to the web, and they often require to use DOM elements to manipulate them. So you'll need to use divs, flags, all of these attributes that you use on the web. You've got now Compose functions that you need to use. How to solve all of these issues? First, there is a great library or a great set of libraries called Accompanist. I've been using on Android for quite some time, and I'm really happy with that. And although, unfortunately, it's not available for Kotlin multi-platform, we've got a really strong community, and the community created a simple version for Compose for desktop. So we've got Accompanist by CR10 that only works on desktop and that you can use on your desktop projects. So if you want to share your code, you can't, at least directly, because this is built only for desktop. I know, I had the exact same thing when I was using it on the beginning. Fortunately, this is quite easy to solve. If you look at the build.gradle file, basically they're just saying that, okay, I'm going to compile this for the GVM. It's the default one. It's not exported for Android. So the solution here is to just add the Android plugin. You're also going to say that you're going to publish your libraries for Android. Since you're going to say that you're publishing for Android, you also need to say that you're going to publish them for the JVM. Since you're now moving to Kotlin multi-platform, you need to define the common main, Android main, and desktop main. And once this is done, you just need to configure the Android to know how all the libraries should be built. So you need to define the compile SD key, source sets, default config, and compile options. And with this, you now support Android and desktop. If we now move to image libraries, you've got the Coil Compose that I've been using, and I'm really happy with it with Android. But unfortunately, it doesn't work outside of the box for the desktop. Once again, we've got a really strong community, and you've got a Camel library that supports Android and desktop. And the syntax of you using that library is quite similar to Coil, so feel free to use it. If you want to share resources, imagine that you want to share an image and you want this code to be shared between Android desktop and the web, you'll need to make some changes. For instance, to do this with Compose on Android, you will call the composable image and then call the painted resource to get the reference for that image. But the R class, this r.rabble, is from Android specific. You can't use it on desktop. So basically what you need to do is to create on multi-platform code to have this image available for Android and for the desktop. How can you do this? Quite simple. You just create a function that corresponds to the image that you want to show. So you'll need to use expect ICAbout, icon about, and you say that it's going to return a pointer. If you're running the application Android, you can use the r.rabble ICAbout. If you're running your application on the desktop, you're going to say actually what ICAbout is image slash ICAbout PNG, because you don't have the r.rabble, the R class. If you want to access the lifecycle, the view models, and everything, you've got the pre-composed library that gives you all of this for free. And what about app? Web, it's still on its early stages. So although you have a couple of components already available, if you want to use them, you still need to use the DOM elements that you're familiar with. For instance, you need to use style with a position, height, flags, margins, all of this. Of course, you can move all of this code to be inside the composable, and then you can just call this composable that you've created across all platforms, but this is a bit time consuming. So sharing the logic on the web works without major issues. You just need to be careful with the generated size of the GS file. Sharing the UI, it's going to be a bit costly in terms of time that you're going to end up trying to have everything shared across multiple targets. How to get everything together. So this is just a brief status of everything. Compose multi-platform mobile KMM is more than stable. Compose is stable. Compose desktop is still alpha-ish. There are a couple of things that I'm hoping that they improve on the next release. Compose for the web, on my opinion, still has a couple of steps further to take. Documentation samples could be a bit improved, although the community and the support is just incredible. So if you have any question, you just need to go to the Kotlin Link Slack and someone's going to answer you there. A couple of resources available. You've got the Jetpack Compose samples by Google, by JetBrains. The GitHub is full of projects. You have multiple applications built with Compose, both for Android and desktop over there and web. You've got the Jetpack Compose internals book that it's really, really good. And of course, once again, the Kotlin Slack. There is just one more thing. I've mentioned a couple of times that the initial setup of the project is a bit difficult. So I've created a library to support this. Basically, this is a sample project that you can use. It's called Alicerce. In Portuguese, this means foundation. And it uses the cookie cutter program to just generate the file that you're looking for. So basically, it's going to ask you for the name, package name, and everything. And at the end, it's going to create a project that's going to work with Android and desktop without any problems. So I think we have 2 or 3 minutes for question and answers. Let me just see if we've got any questions.
Let's see if we have any questions. I don't see. Please, if you have any questions, post them on the chat, on the live chat. I don't see anything at the moment. Quick question. So,
yes,
what is best for people to contact you? Is it your Twitter that you have there on the slide?
Yeah, I think Twitter it's the best approach to contact me, especially because I either receive a tweet or I receive a Twitter and email. So it's the best way to contact me.
Also, we just got the question: can you share the link to the library that you created to
Yes,
on the chat, please?
yes, of course.
Thank you. And I have a quick question. You mentioned at the start that you're one of the leads for the Google Developer Group in your area, and
Yes.
I was wondering, like, how is the community now there with COVID and everything? Have you been active? Have you been doing online events?
Yeah, basically, on the beginning, we tried to make a couple of online events, and what we noticed was we probably had like 10, 15 people on the online event, and the streams. After the online event, we publish the streams on YouTube, and it's when people often watch the streams. So instead of doing it live, we noticed that it was better just to release it when we had them available.
Okay.
What we noticed that it's still working. It's the DevFest. We did instead of doing one by region, we also created a DevFest Portugal, and that
Okay.
gained a lot of attraction. And a part of that, we've noticed that people prefer to use the Slack than watching more talks.
Yeah. Okay. Nice. When was your DevFest?
Ours was at the end of December, yeah, on the beginning of December.
Okay. Nice. Nice. And it was all virtual, right? Or
All
in
virtual,
person?
yeah.
All virtual.
We don't have a date for when it's going to be either hybrid or presential.
Yeah. Yeah. It's quite early. So do you want? You've shared the link here. Let me just paste it. Give me 1 second.
Yes.
Copy the link. Here's the link to the library. And I've also wanted to paste. I don't think we have any other questions. Thank you very much. That was really interesting. You can find a lot of the resources. You mentioned quite a few resources there. So if anyone has any more questions, just reach out to you on Twitter, and or actually the talk is gonna get recorded, is getting recorded, and it's gonna get posted later on YouTube, so you can rewatch it if you didn't catch anything, basically. But yeah, thank you very much. That was great. So now I'm gonna remove your
Thank
presentation.
you, everyone.
Have a great weekend, and yeah, thank you for giving your Saturday.
Thank you, and happy weekend, everyone.
Thank you. So let's see. So now we have a break. Link to the slides, perhaps. So Carlos just dropped off the stream. I think it's best to contact him on Twitter to get the link for the slides. I'm sure he will be more than happy, but you can watch again if you want, and when we upload the videos. I'm just gonna drop really quick David's Twitter account, the previous speaker, he shared with us. So now we have a 30 minutes, not less than 30 minutes coffee break, and we'll be back on the stream in less than 30 minutes with 2 more talks. See you in a bit. Hello everyone again. We're gonna be starting in about 9 minutes. So we've got two more talks for the last part of the day. Thank you everyone that has stayed together with us for the whole day. Hope you enjoyed it. I'm gonna try and add our next speaker. I'm not sure if she's ready. Let's see. Hello.
Hi,
Hey, how are you?
good. How are you?
Good. Sorry, is it Divya? Is it that?
Yes, yes,
Yeah.
perfect. Got it.
Perfect.
Spot
Cool.
on.
Nice. Where are you based?
I am actually based out of San Francisco, but currently I'm in the East. I'm in
Okay, cool. So that's really cool. Uh,
it's
what
just snowing outside, so
what's the time?
it's 11 a.m.
Okay, that's not too bad.
Yeah,
Yeah,
it's not bad.
yeah, that's okay. Nice. So we're gonna start in a bit. We've got a little bit more time. But yeah, anything? Are you gonna share your screen? Everything?
Yeah,
Okay.
yeah.
Can
Do you want me
share.
to share my screen quickly just so we can?
Yeah, of course. We are live now, but yeah, we can. Uh,
Okay, awesome. Okay. Yeah, I think this.
yes, and I can add it. Let me see. Yeah, okay, cool.
Awesome. Thank you.
I'll add it when we need. Cool. Let me add my screen for now. Give it a few more minutes. How you been? How's your Saturday? I
Sorry,
guess. How is your Saturday?
it's going. It's just starting, so Um,
Yeah, yeah, true.
but I've been enjoying like bits and pieces of the talks, and it's been great. The virtual, like the hybrid aspect of it, which is like in person versus this thing. I think that's really commendable the way you guys have pulled it off. So
I think it's really interesting. I'm glad that we did the in-person bit as well, even though like all of us, like until like up to the time that we did it with Omicron and everything, we're
right,
all kind of like afraid, right?
yeah,
But it's actually turned out to be really good, and everyone like there are quite a lot of people here. It's nice to mix with the community again and
yeah,
talk to like strangers about things,
yeah,
about tech and stuff. It's really interesting. A lot of interesting people here.
yeah.
Yeah, it's been
No, I
hopefully. Yeah.
yeah. Go ahead.
I was gonna say hopefully we will start getting more of those like in-person events soon when things are spinning up again.
Yeah, that's what I was going to say. I'm hoping, I can't wait to, because before the pandemic, I would attend like conferences in person, and it was so amazing to like meet all the people, and like you just get so much more out of the conference from in the in-person aspect. And so I can't wait, because it's been more than 2 years now, and I just can't wait to attend my next like in-person conference.
Exactly. Like I think like we haven't met for 2 years now with the community, and we've been building up for the DevFest and everything. Yeah, it's been a lot of work as well. So it's nice to see finally like coming through.
Yes, I agree,
Front of, yeah,
100%.
it's quite nice. Cool. So I think we have a little more time. Just wait. So, are you currently contracting? How? Where do you work?
No, I work for a startup called Blue Owl in San Francisco.
Okay, nice.
I've been there for a year now, and I basically lead the Android team there.
Okay, and what do they do? What's
They're in the auto insurance tech space.
did you
They're
say
in
virtual?
auto insurance tech space.
Okay, okay,
Mhm.
cool,
Yeah.
nice.
Where are you based? Are you in UK or Ireland?
Yes, yeah, we're actually at the currently, if you can hear like all the noises of the background, we're in the organizers' meeting room in the DevFest in London, and the
I see.
in-person event.
I
And
see.
yeah, and I'm based in London as well. Yeah, I work for a consultancy in London.
Nice.
Yeah.
Actually, funny story. The only time I've been to London is for DroidCon London back in 2018, and I fell in love with the city. I hope that I'm back there soon once all the pandemic issues are over. Because I love the city. I was there for like 5 days because I made a trip out of it, but I loved every aspect of it. So
There is just before Omicron hit, there were a few conferences that actually did an in-person event. Like there was a React Advance, and I think the second one might have been DroidCon. I'm
yeah,
not
I
100%
think it was
sure.
DroidCon London.
I
Yeah.
think they did an in-person event as well, just before, which is exciting. Like
Yeah, I can't wait to be back. So
yeah,
hopefully in the next couple of years.
yeah. Hopefully, I think the next year will be good. And cool. I think we can. I'll introduce you and we can start.
Okay.
So, hello everyone again. So we're back. We've got two more talks for the remaining of the mobile track. The next talk is with Divya, and we've got she's gonna talk to us about architecting Kotlin multi-platform app. And I'll share your screen now, and the floor is yours.
Awesome. Hi, everyone. I'll introduce about the topic a little bit before talking about myself. So, I appreciate all of you being here. I know this talk is towards the end of the day, so I'll keep it quick and short, but hopefully helpful for everybody. So most of us are writing Android mobile apps in Kotlin these days. It has proven to be pretty easy and a mature, statically typed programming language, which not only has benefits like it's concise, safe, but what some of us might not know is that it's interoperable with a bunch of languages and frameworks, which makes it useful not only to write Android apps, but a bunch of other kinds of apps as well. Also, writing the same app with similar features just for even two different platforms like Android and iOS comes with its own headaches. And especially when probably the business logic behind the app remains the same. And hence the topic for today, which is Kotlin multi-platform app and how to architect it. So, hi everyone, my name is Divya Jain. I am a mobile app developer currently based out of San Francisco. I have been developing mobile apps, especially Android, for over 7 years now. I'm very fond of and pretty active in the Android community. So you can find me on Twitter through the handle here, or on GitHub, or even on my email. So feel free to reach out for any technical help, questions. Before I continue, I would like to give a big shout out to the organizers of the DevFest here for giving me this wonderful opportunity. And I am super grateful for all of you for being here listening to me. So, as I said before, Kotlin provides the benefit of programming for various languages. You can still reap the benefits of native programming, which provides for quickly writing and sharing code among multi platforms in one single code base. And hence comes Kotlin multi platform, which is basically an SDK that enables cross platform development. Now, there are two parts to it. There is Common Kotlin, which is basically a platform independent code, which has the languages and the core SDK and basic tools, which will run on any platform. For example, to support serialization, HTTP calls, managing coroutines, etc. And then there is platform specific Kotlin, which is any code that is platform specific. Now, it is interoperable, so you can access native code and its capabilities. So the idea is that there is complete support for extracting all the business logic into common code, which can be used to run the code on various platforms, which basically means there is quick development time, easy scalability, and maintainability. And also, you can reuse platform specific code as well if there are similarities. Now, there is also something called an expected and actual declaration mechanism, where you can define an expected declaration in common shared code, and the platform's specific code provides the actual declaration corresponding to the expected one. And we'll deep dive into all of these. And we'll also see an insight into how we can quickly and cleanly develop mobile apps for various platforms by writing one single shared code comprising of all the business logic. Now, one thing to note here is that Kotlin multi-platform only lets you share what you want to share, but it is also independent of the UI. So it sort of enables you to independently develop UI in whatever language you feel comfortable with. For example, in Android, you can go down the XML imperative way or experiment with the new Jetpack Compose that everybody's been raving about. Similarly, for iOS, you are welcome to develop UI based on the old storyboard way or use Swift UI. So Kotlin multi-platform just facilitates sharing all the business logic. So here's what a newly created Kotlin multi-platform mobile project structure looks like. So as you see here, there are three essential components. One is the shared module, which is where you'll end up writing the core application logic for both the iOS and Android applications. And this module builds itself to an Android library and iOS framework, which is used as dependencies in the individual apps. Now, this module is built using the multi-platform Gradle plugin. Now, when we use this module in Android, it's equivalent to a simple include in the settings.gradle. But for iOS, it is compiled into native code, which is used as a framework in the iOS app. So we have that is the shared module. Then we have the Android app, which is the Kotlin module that runs as the Android application on the Android device. And then you have the iOS app, which is basically the Xcode project that runs as an iOS application on an iPhone or any other iOS device. Now, our main focus is the shared module, which contains the common logic for both Android and iOS app. Now, in this module, you see further three folders, which is the common main, the Android main, and the iOS main. So let's first delve deeper into what those are for. There is a common main, which, as the name suggests, common main contains code that works as it is on both the platforms. There are classes, functions, which are not dependent on any platform specific thing. Now, this is where you'll probably have all the business logic, which can be unit tested since it doesn't depend on any of the platform dependencies, including the data and network operations. Just hold on 1 second. I'm just... Yeah, sorry, technical. So as I was saying, the common main is the name contains code that works as it is on both the platforms, which is classes, functions, which are not dependent on any platform specific thing, which is where you'll have all the business logic, which can be unit tested since it doesn't depend on any platform dependencies, including data and network operations, etc. But sometimes the logic might be platform dependent. For example, something like retrieving the OS version, which will obviously be different for Android and iOS, which we are currently using, or the way we store key value pairs in something like local storage, which corresponds to shared preferences on Android and user defaults on iOS. Now, these kinds of cases are handled by something called the expect actual mechanism. And this is what you see here. The common main will contain these expect declarations as well. And then it's expected that the Android main and the iOS main folders contains the actual declaration corresponding to the expected ones in the common module. And the best thing is this will be checked at compile time. So the compiler ensures that every expect declaration has the actual one in the platform specific code. So a very simple example is determining what version we might be using. So as we see here, we have the expect declaration of a class platform in the common main. And then we have the corresponding actual class platform implementation itself in the iOS main and the Android main with their own specific implementations. Now, a couple of things to notice here is the expect and the actual has the same name, should have the same name, and should be part of the same package. That is how the compile time it is determined to see if they are matching, and if they are not, it will throw a compile time error. Now, in order to create a Kotlin multi-platform project, first you would need to install the Kotlin multi-platform mobile plugin. So you can go to your Android Studio, in Preferences, go to Plugins, and search for this one, the one that you see on screen. I believe any latest Android Studio IDE version can be used for this. The one great benefit of using this plugin is that it lets you run and debug iOS apps as well from Android Studio itself without having to switch over to Xcode again and again. Now, once the plugin is installed and the IDE is restarted, let's see how a new KMP project is created. Now, when selecting to create a new project, you will see an option for KMM application, which basically stands for Kotlin Multi-Platform Mobile. Now, once you proceed, you might also come across this screen, which gives you a lot of information about the structure of a KMM project. So reiterating what we saw earlier, there are two separate app modules, which is the Android app and the iOS app. And then there is a shared module, which shares all the logic common to both the platforms. And this shared module is what gets built into the Android app as a dependency or a library, and iOS app as an external framework. Now, as a sample app for today's demo, I'm going to show you how to quickly build a very simple app that shows a list of books. By the way, this is a list of 10 greatest books of all times in case we have voracious readers in the audience. So yeah, the app shows the list of books with their names, a brief description, and the author of the book. This app is available on my GitHub link, and which is included in the slides. So anybody is welcome to check it out. And here in the next couple of slides, I'll have screenshots of all the important pieces of code, which is what I'll go through. So now first let's determine what we'll need for an app is the book data model, representing the attributes, which are the name, the description, and the author. Now, this is business logic, of course, because it's not platform dependent. And so you can create this as a data class in Kotlin. And the main thing to note here is that this is created in shared module and it's independent of the platform. So all the apps utilizing this model will see the same book structure. Now, next is the books repository. For simplicity here, I've just hard-coded the list of books, but in a real-world application, this can be a combination of local storage like databases, which is SQLite in Kotlin, or this can also be a place where you would fetch data from a server or any API. Again, the thing to note is that this is business logic, and you would want this to be consistent across platforms, because whether it is your iOS app or Android app, you would want to see the same list of books on both the platforms. So we also would put the repository and this logic in shared module. Now we already have the data and the logic to retrieve that data in place in shared code. All that's left is displaying this data in a list. Now this is UI, which is platform specific. So we would move to the Android app and implement the code to display a list, which is what you see here, which is this is a code to show a recycler view with its adapter. Now, all the Android developers are already used to writing this code. But again, the important thing to know here is that the data for the recycler view is coming from the book repository, which resides in the shared module. And overall, there is a clear abstraction of the business logic from the UI layer. Now let's move over to the iOS UI. Just a disclaimer, I haven't done iOS development much before, and the Xcode project that gets created with this multi-platform mobile app is usually a Swift UI project. Now, for people who might not know, Swift UI is very similar to Jetpack Compose. It's a declarative UI framework where you are describing the UI and there is underhood functionality to lay it out on the screen. So it was a bit of a curve to learn Swift UI, but I feel it's still easier and faster from the development perspective. So what you see here on the screen is the only code you need to write to display a list. Now, as you see here, there is a navigation view, which under it has a list, the data for which is again coming from our book repository, which resides in the shared module. And for every book, we are passing it to the book row, which puts the name, the description, and the author in the way that we have described. But this many lines of code, and it's an exact same result from the UI perspective on both iOS and Android. So this is what the app looks like on both iOS and Android. And again, the great benefit is they are sharing the business logic. So tomorrow, if someone changes one of the books or the way the books are sorted in the repository, or is fetching the list from an API or a local storage or any other change from the functionality perspective, it will reflect on both the platforms simultaneously, which makes it easy to test, scale, develop a lot of other features much faster and efficiently. Now, what we saw was a very simple application with static hard-coded data. But in real world, of course, the data is much more complex, and there is an essential constant need of interaction between the client and the web servers through various HTTP calls. Now, from what we all have seen till now, the first thought would be, why not just use the networking libraries we are already familiar with, like Retrofit, OKHTTP, or anything? This way, we already know that Kotlin multi-platform lets us utilize the platform-specific APIs, so we can easily create an interface in the shared common and just implement it in the platform-specific ones, right? But today we are also going to talk about a multi-platform library that actually lets you network or call networking APIs without the platform differences by adding one single dependency and writing just small lines of codes. Again, this is in the shared module. So this also facilitates write once and use anywhere concept again. So this is the Ktor world. As it says here, it's actually, again, an open source library that lets you create asynchronous client and server applications. Anything from microservices to multi-platform HTTP client apps in a simple way. And it has an asynchronous multi-platform client, which allows you to make requests and handle responses as well. Not only that, it also comes with functionalities around JSON serialization, authentication, etc. Ktor also provides the HTTP mechanism through multiple HTTP engines. So there'll be a common module and then platform related engines which processes those requests. So for example, if in the book app that we saw, we want to integrate API calling ability, we would add the dependency for Ktor by using the OKHTTP engine, which is for Android, and the iOS engine that it provides for iOS. So once the dependencies are added in the common main, you would want to just create an HTTP client by calling the constructor, which is shown here. And then based on the dependencies which are added in the build script, one of the engines which is available to Ktor will be selected at compile time. Now, if Ktor can't find an engine, maybe because of the platform and the dependency discrepancy or something, it will throw a runtime error. I wouldn't go deep into the implementation here, but basically, after this client is created, you can actually just make HTTP requests through the suspend functions and coroutines in the common shared module itself. And once you get a response, you can handle the response again in the common module itself before presenting the data to the platform specific UIs. Now, the couple of things to note here is that it would still require you to ensure that each of the individual apps have the necessary permissions. For example, the internet permission or the storage permission if you need. Also, since Ktor is built around coroutines, you would have to ensure to call the functions to make the HTTP request in the individual scopes that it needs, as into how suspend functions work. And in iOS, there are equivalent callback mechanisms. Now, there are great examples of Ktor integrations with Kotlin multi-platform that are available on GitHub. So I would highly recommend to check it out. But the whole idea is that it lets you easily network without, again, depending on the platform specific overheads. So it's another great way of encapsulating all the networking and the data logic away from Android, iOS, and all the other individual platforms into the shared one. And it sort of makes or ensures that UIs are just dumb and show the exact same thing, irrespective of what platform it's rendering on. Now, let's briefly summarize how a Kotlin multi-platform mobile app looks like with a clean architecture. Now, I don't think I need to really emphasize the importance of architecture behind an app. Clean architecture always ensures the app is scalable, maintainable, easily testable, and ensures a consistent and efficient user experience. So for a KMM app, there are all these different modules. There is domain where you'll have your data classes and models. There is data source, which is sort of following along the repository pattern. It can be either a local cache, like, as I said, SQL Delight, or a network source where, as we saw, we synchronize with web servers through Ktor to get data from APIs. Then you have your use cases and different user interaction handlers. Now, all this is business logic, which can be abstracted and shared through pure Kotlin in the shared module, which makes up the business layer. Nothing to do with platform specifics. And then below, you'll have the platform specific UI or services, etc., which is where the native UI development comes into place, depending on what kind of a platform it is. Now, before I conclude, I would like to reiterate why KMM and why KMM and what are its benefits. So just because there is shared business logic and a single code base for it, as you can realize, there are significant savings. Writing the code once and reusing on multi-platform has its own beauty. It enables much faster development and cost savings. Another very important thing to note is that it's easily debuggable. One can easily unit test the business logic, which also facilitates bugs being caught much early on and less production bugs. There is a lot of flexibility. You get to share only what you want, and you're still providing a consistent native experience to the user, which is where Kotlin multi-platform takes precedence over other hybrid uh, platform frameworks. Now let's also talk about where does Kotlin multi-platform stands at the moment. We know that it's in alpha currently, but expected to go to beta in spring of this year. So fingers crossed that would be soon. Now, despite all this, there are tons of apps that are already using Kotlin multi-platform in production, which is commendable. We have a lot of success stories like Netflix, Cash App, Quizlet, etc. Now, all these companies have their own use cases and different reasonings about why do they use Kotlin multi-platform to solve, again, various kinds of problems. But some common benefits still include performance improvements, developer satisfaction, not only writing the common shared business logic code only once, but also the flexibility to experiment and leverage modern platforms for UI development, since those are abstracted out from the business logic. There is a decoupled code from the platform specifics, which leads to way less errors, and there is feature parity across platforms, etc. So ultimately, Kotlin platform holds all the key promises and possibilities similar to Kotlin and emerges as a well-equipped solution for cross-platform app development projects. And with that, I am again very grateful for all of you for listening to me. Thank you so much for being here.
Thank you very much. Let's see if we have any questions from the audience. If you have any questions, please post it on the chat. Perfect. I'm not seeing anything. Again, your talk is gonna be recorded, so people will have a chance to watch it again.
Awesome.
It should be out this week in some point. Yeah, thank you very much. Have a great rest of the day. Nice meeting
Thank
you.
you. Thanks.
Bye. So let me add the next speaker. Hello. Hello, Natalia. I think you're muted.
Definitely, I was muted. Sorry.
That's fine. How are you today?
I'm doing good. Doing good.
Where are you based?
Barcelona.
Ah, nice. We have like people from all over today.
Oh, really?
Yeah, it's been like
Where?
so we have people from the US. The few talks we had before, it was a guy from Portugal. So it's been like an international panel. Um, the whole
Amazing.
web track.
Okay. Can you see my
So
screen?
not yet.
That's strange. Let me see. Because has lost permission to capture your screen. Follow these steps. Oh, okay. For some reason. Oh no. Okay. Let me give.
You need to
from-
drop off and yeah.
Yeah,
Cool.
I will be back. Okay.
Okay. Cool.
Okay. Sorry. Bye.
It's okay.
So, Daniel has asked, what do you use to measure performance, maybe work, etc.?
So we're gonna wait for a few more minutes while Natalia is sorting out the permissions for the share screen. So this is our last talk for the day for the web track. And thank you all again for being with us. And let me know, Natalia, when you are ready.
Wonderful. So we have shown up on insights into benchmarks, repos. You also add
One moment. Okay.
tutorials or other case studies. Is there anything you'd recommend? You can send them out in the comments here. And they'll be on the YouTube forever or forever and a day.
I think Natalia may have dropped off to restart the browser or something like that. We still have time. We're quite ahead of schedule. So for anyone that just joined, we're just waiting for Natalia to restart her browser and come back in because we need to sort out some technical permissions for the search screen. She should be with us in a few minutes, and we will be able to start the talk.
So,
If you are just joining us now and you've missed all the previous talks, or if you were busy earlier and you wanted to watch one of the previous talks, or if you're not sure about something, the videos of the previous talks are going to be uploaded on our YouTube channel, and you're going to be able to watch them again later.
users over the coming weeks.
Right on time, I guess.
Hello? Have
I don't-
you?
I heard you were talking about how many years.
I guess so.
Yes, nice. Okay, perfect. So I'm just going to present you. So our last talk for the web track for today, we've got Natalia. Is going to talk to us about micro frontends. And I'll share your screen with everyone, and you can start. Enjoy, and yeah.
Yeah, thank you so much. So hello, everyone. My name is Natalia Bendito, and I'm currently working in the role of Principal Program Manager with the Azure End-to-End Developer Experience team at Microsoft. I lead the efforts for JavaScript and Node.js, and before that, I was a developer for a very, very long time, and a software and solutions architect. And I also joined the Google Developer Expert Program in 2020 for Angular and web technologies. And today we will be speaking about micro frontends and how much joy and fun they are, right? I guess so, yes. So my journey with micro frontends started in 2019 when I started experimenting with them in diverse forms. I was back then part of a team that was working with a very large monolith. I think you heard the word, but we're going to go over it in a moment. And we supported many different projects, and we needed to optimize the whole architecture, right? Because I had been experimenting and giving so much thought to the topic ever since, and discussing it with so many people. My views on micro frontends have evolved and changed considerably ever since 2019. And they have changed because whenever I choose an architecture pattern or a framework or whatever tool I am working with, I always ask myself this question a lot. Why? I can't stress enough the importance of asking yourself and your colleagues why. Challenging yourself and your beliefs about technologies constantly helps you grow as a technologist, as an expert, as a developer, and get better and improve, right? And you always need to clearly define what is this problem that you're trying to solve. And so by taking care or by taking a certain solution route, what exactly are you solving? And so I asked myself, why all along? Let's remind ourselves how we ended up with the diametral opposed pattern to micro frontends or microarchitectures, the monoliths. Monoliths evolved to be what they became naturally. Nobody designed them to be like that. We had centralized deployments, typically on-prem, that consisted of many layers. The infrastructure, the data storage layer, the data access layer, the business logic layer, and obviously the front end, all put together. And they started growing and growing and growing. And they became those massive stones that you couldn't decouple, you couldn't break apart. But we took measures, of course, and those measures paved the way to what micro frontends are today. So let's review them. We wanted to reutilize code to avoid duplicated code, so we did not have to deal with huge maintenance efforts, and we could continue to scale in a more controlled way. Those huge monoliths, monsters, right, took a very long time to build and deploy, and forced everyone to bump versions and patch dependencies. So we figured out ways to make everything a bit more manageable from both a development and maintenance perspective, and also scalability and deployability. And we resorted to modularization, also in the front end, and it worked, right? Those huge monoliths now are thought in a different way. And when we started thinking more about performance and how we could work in delivering a better user experience from the very, very structure of our projects, from the very build system, right? And the strategy behind it, by splitting code into chunks. So we could not only work on code more efficiently because it was encapsulated, it was smaller, but also we could optimize its maintenance and improve runtime performance by, for example, categorizing code and inlining or requesting front-end assets at page load, while we deferred or asynchronous load everything that is below the fold. Those strategies were...
Sorry to cut you. Is your battery running low? And is your battery at 1%? I think.
Is it? How do you know that? Oh, okay. Yeah, nice. Good
Yeah,
catch.
there was just a comment. Yeah, cool.
It's going. Yeah. Okay.
Sorry to.
No, it's okay. There we go. Thanks for letting me know. Yeah. So that code splitting was implemented directly at the build or at the front end setup. And we also dedicated a lot of time to design and implement design systems and component libraries that allowed us to reuse a single component over and over, composing and decomposing layouts and making sure we only had to maintain once, right? Now it's running a bit slow, but let's hope it doesn't crash. So if a component changes in specification, how many of you have gone through the, we are building or we are working on programming a component and the specification changes? We just can create a new version of it and extend it. And we did not have to break whatever already existed, which was especially a problem or was especially important for large projects that had hundreds of users already in production. The key was splitting, decoupling, atomizing, and using composites to build other blocks. With this kind of configuration, we could already assign more specific building blocks to different teams and work more agile, right? We can say, okay, you are going to be taking care of the video component while we take care of the CTA component, right? That's an exaggeration, but we could do it. And if we bring back this slide that we just saw, and we think of each one of those components as reusable modules, it all starts to make sense as how this modularization abstraction is the root of micro frontends that allowed us to break away from dependencies and reuse code to compose interfaces. With this pattern in mind, we can solve a myriad of problems. We could build more uniform and coherent and consistent interfaces, and the reutilization of abstracts made code lighter and more performant. Instead of having, like, for example, let's define colors in every component, we just abstracted it to a different layer, and we could all reutilize or consume from this code. Mechanisms to easily restyle components, accessibility, more optimal animations, it all got simplified once we broke things apart. But there was a problem we could not solve in the context of monoliths. Imagine you have a feature that is connected to a business domain, and this feature is being constantly maintained, as opposed to another one that hardly ever gets any maintenance and is no more further developed. But then again, when you release your dynamic capability, you have to release the whole code base, right? Independent deployability allows us to fully leverage encapsulation, at least in theory. If we have to materialize a scenario like this, like the one we will introduce right now in the next slide, imagine component 1, 2, and 3 owned by different teams who decided on different technologies, mapping to independent business units, and have very, very different development and release cycles. We can, in theory, decouple to a point where we can even guarantee that every small part is able to be rebuilt and redeployed in isolation, and it can fail safely and silently. For this system to work, though, we should respect some principles that I'm going to explain in a moment. There should be one and only one business domain associated with each unit. There should be an independent team owning the feature and making their own architecture and processes choices. And there should be no shared logic. But let me tell you what is the real independent type of deployment to support micro frontends, the one that we don't own. And that is something that we can accomplish in the cloud. We're incredibly lucky today because we're living in the era of native development in the cloud. And cloud development unlocks a vast amount of features and technologies we can use to simplify architecture, decouple systems, minimize third-party dependencies, reduce the total cost of ownership, and in the process, enhance both developer and final user experience, which is always very, very tightly coupled with performance. And we hear sometimes, the cloud is complex because it provides too many services, but we don't need to use them all, and definitely don't need to know how to implement all of them. We don't need to know the nitty-gritty details of the mechanisms they enable. And we definitely don't have to worry about provisioning the right infrastructure or working in its maintenance. The cloud allows us to break down monolithic complexity not only into multiple services, but also delegate a great deal of responsibility to service providers. So it's their problem, not ours anymore. So we can move faster, iterate quickly, and deliver in time. This is the ideal setup for microarchitectures or micro-star architectures. To sum up, adopting this type of architecture and cloud technologies enables us to reduce the cost of ownership by fully leveraging these managed infrastructures, provisioning, and dozens of additional services to implement, to automate, to observe, to monitor, to whatever we need with our deployment, our code. We simplify the architecture per block and achieve system decoupling, which allows us to iterate on features and services independently as they map to different business units and have diverse requirements on iteration needs, which also translates into higher developer productivity, something we always wish for, with the consequent satisfaction of everyone in the team. If we are more productive, if we feel we're delivering, we're always happier developers, right? And we also minimize dependencies between parts of our system, and we can guarantee for each micro part to fail silently, Cloud native microarchitectures are really impactful in a positive way. They enable teams to work in specialized tasks. They enable developers to adopt and experiment with new technologies and services, and they simplify the process required to deliver functional, complete software. But this audience that is here today, you're probably front-end developers, and you're wondering, what's in the cloud for me, right? As a JavaScript professional, what is that I can benefit from that is really relevant to me, that can help me if I move in the path of micro frontends, that really resonates? Aren't micro frontends only run on the client side? What do I care about the cloud? And I feel that the very first thing that works in the cloud entirely that you need to consider are all those developer productivity and collaboration tools that make it easier to work on different parts of a whole application, even remotely. IDEs or online integrated developer environments, code spaces, hosting services, package repositories, all these that enable you to call dependencies from anywhere. That's definitely one of the game changers, and that's possible because of cloud resources and infrastructure. But also the cloud has enabled us as front-end developers to ship applications end-to-end without having to worry about deployment pipelines, managing required infrastructure, and remove the need to code and maintain backend servers of our own, which was a problem. And many of us didn't want to learn to do that. Think about Node.js serverless functions, going the serverless way. Of course, serverless functions can be written in other languages than JavaScript, but what matters to us as front-end developers is that they can be written in TypeScript and in JavaScript and run in a Node context, and we can talk to other backend APIs, and we don't have to worry, again, about writing that backend logic that supports running these tiny functions on our own. We can write a simple API and access it as an endpoint via HTTP in minutes, right? And this strategy allows us to further decouple our applications while we keep the complexity of the overall code base in check. We reduce maintenance efforts, we deliver more quickly, and we benefit from existing infrastructure that we are not responsible for. Again, we don't have to worry about it. And it's not only code and APIs. You can run serverless, you can run databases as software in a serverless fashion. And I know that many front-end developers find the mention of anything outside the UI or the user interface very daunting, and it's perfectly fine. Our scope has really become very large. We cannot control everything, and we really need to normalize being front-end developers with different focuses. But the reality is front-end systems become more and more complex each time, and we try to make UIs more dynamic and performant for our users, and we inevitably need to bring a lot more logic to our end of the stack, and enable dynamic requests for data as we react to events or trigger events that occur in combination with a myriad of services. And for that, we need additional infrastructure, but we don't have to, again, take care of it ourselves. We can leave it to the cloud providers and the many platforms that enable that. And because we don't have to maintain that, we can split our frontends into many smaller applications and reuse them in many ways. And that also enables us to work with different models of data. This is very important nowadays because depending on the nature of the application, it will be the nature of the data. And I'm sure many front-end developers here remember the day when we were stuck getting deeply nested objects back from the front-end APIs, because that was the easier way for them to deliver the data, but the hardest way for us, right, to work with it. We had to then clean it, we had to parse it, we had to iterate those horrible objects. Those were the days when the majority of data was normalized and stored in tables. The cloud and serverless models also enable us to split our data in smaller databases depending on the type of data we're working with. So if we're splitting our application into micro frontends, we don't have to just work with one database in the backend, right? And we can even write our own GraphQL APIs with TypeScript, for example, and we get only the data we need at all times. And we don't have to process it in the front end anymore. So if your micro application is dealing with data and a use case that no other service is dealing with and works with it in isolation, and then you are enabled to put it together end-to-end, or to put together end-to-end an efficient solution for your particular use case. But if your application at large needs to aggregate data and reuse it from many services, you will also be able to do that using an API-first model. Most cloud databases will allow you to create different logical databases in the scope of a same deployment, so you can also partition your data. Like, if, for example, if you have if you're dealing with multiple micro frontends and you want to have a database per each one of those, you can do it in a single deployment. And depending how independent are the teams working in the many different micro applications and how feasible it is to share API keys or certificates or whatever enables access to that data, you can also work all together. And those concerns are largely addressed by cloud providers. An aspect that should definitely help you decide how you will manage data and services behind your micro frontend is the workload supported by it. An effective workload isolation strategy can help you identify, for example, read-only, operational, and analytic components and decouple them into different micro frontends. And this strategy helps you with preventing that micro applications compete for operational resources and enhance the overall perceived performance for dynamic modules in the front end. For example, let's suppose you are developing a gaming application, right? And one of your views will be composed of a leaderboard that is read-only, the actual gaming screen where all the action happens, and a single view of all game global statistics compared to other players. You could definitely connect each workload to a different node of database, I'm talking here, with a simple logic and the driver and an SDK and all these goodies that the cloud providers offer us. We will talk about state management in a moment because that's a real important component of this use case we're presenting. But another thing definitely you should make sure to synchronize is authentication and authorization for all of the services running. And this is very easy to do in the cloud with a federated system. So if you don't want to federate access with, I don't know, tools like Auth0, for example, you can resort to data duplication. And data duplication is not a bad practice, particularly when there are systems in place to guarantee replication and synchronization in an automated way. However, there may be cases when data is shared between several micro applications, and particularly when data is of a type that tends to generate great volumes of data over time or over a short span of time, like Internet of Things. Consumption should be in real time, and synchronization may suppose a great effort. Instead of duplicating an API-first approach could help maintaining a single data storage layer that will serve different services with or without sharing additional infrastructure. Again, all made possible by the cloud. But like we already mentioned, at the end of the day, what really matters to everyone, to the front-end developers, is to make sure that no matter how many fragments you're working with, once you compose your user interfaces with those micro frontends, the user experience is not negatively impacted. So every time I speak about micro frontends, I stress this. This is why, in my particular opinion, micro frontends should always be designed from the user interface top down. So the most important thing should always be a cohesive user interface, a coherent user experience, a unified state across multiple parts, and also optimal download times. This is why if you and your team decide to go with micro frontend strategy, you need to start by deciding how you will integrate all the parts, how you will load them, or how you will coordinate them. And that process is oftentimes referred to as orchestration. There are frameworks that can help you bind all these pieces together. And there are also tools that can help you share common dependencies, even between remote deployments. What exact tools you need or are helpful for you, I cannot tell you right now, because it will very much depend on what level your micro frontends coexist in the same context, in the same page, for example. If they are loaded in one single page, you probably will need something like a host or app shell to load them. And we can think of this as the host, the runtime that will expose shared and vendor dependencies to everyone so everyone can consume them. And this host should also be owned by an independent team, as we were talking about independent teams owning each part. The host is also a part that should have direct responsibility or direct accountability of a single team. And we will see why in a moment. About 1 year ago, or 1.5 years ago, because I think the stable release was in November or October 2020, I started exploring Module Federation, which is a plugin for Webpack that allows you to perform static dependency analysis of remote modules with an interchangeable host/remote model in mind, where the host is always the first runtime to be loaded. In this example, each application is bundled independently with a certain configuration and hosted on a different origin or domain than the host, right? And this is a representation of how federated modules work. If we have a remote container and a host, the only difference between the two, again, is or what makes the host and the other the remote, like we mentioned before, is that the host loads its runtime first. These roles are interchangeable. So if you load one of the remotes first in another context, that will be the host. And the share scope is basically the object where the provided modules live with their own definitions. All containers run a version check of dependencies, and they load them from this share scope. And they also validate parameters like strict version, if they are singleton, etc. And if a share module is in the share scope coming from the host or the initial runtime, like, I don't know, for example, React, and versions are satisfied, it is the one used. And the remote won't require its own dependency. If it's not available or the version is different, the remote falls back to loading its own dependencies. And this works really, really well in theory. And there are claims of large deployments working well in production. But in my opinion, when deployments are not owned by the same organization at large, the model can only succeed, or this model can only succeed with a very, very well strategized governance model, which in turn defeats the purpose of independent deployability and independent teams making autonomous decisions. Because if you have a governance model that is ruling what you have to load, what kind of framework you have to use, then we're defeating the purpose. So I feel that it is an option for certain use cases, but perhaps not the use case when development teams are not coordinated. They don't talk to each other, they don't know each other, but they're going to put all their development in one page. Then I think that this is not the right solution. In both cases, governance should be enforced, again, by the host team at all times. And that becomes a new blocker for fast iterations, right? So I am not really entirely sure the problem with independent deployability has a solution yet, except potentially for one, which is serverless backend for frontend in the cloud, no JavaScript frameworks, so you don't have to be loading multiple JavaScript frameworks or multiple versions of multiple JavaScript frameworks. And instead, we use browser-stable APIs, and we include publication subscription mechanisms, whatever they are. We do ECMAScript imports or module imports, and we use latest long-term support node runtimes, pure CSS, everything that is available to everyone, and governing on the premise, of using the latest amount of third-party dependencies at build time. So you don't have to worry about analyzing code statically and deciding what dependencies are available and what not, and what you will be shipping, what you will be loading. Now, finally, let's think about distances. It is in many cases logistically impossible to meet a certain performance benchmark if your database and your applications are deployed in a single node, right? And at a single region of the world, right? There is no way to overcome a certain latency if you have to send data and your application to your users from the other side of the world, right? If the application is not distributed. If your application is a composition of cloud-native parts, including the data layer and the micro applications, or a globally distributed application deployment, latency is no longer a problem. Additionally, a micro frontend architecture can help you segment and customize application configuration per geographical region and even per user tier. So you can filter out query results to a database with data locality in mind, avoiding large data set scans and improving speed. And when it comes to the front end that is going to be rendering the data, you can deploy and build with an exclusive to a region configuration in mind too. And then you are going to serve exactly what the user, what the customer needs, even per micro frontend. And finally, you can rely on the ultimate strategy for super optimized micro frontend deployments that are cached near the users. And those are deployed at the edge of the network and use edge computation and databases to operate. Those micro frontends do not only store, but also transform or process data at and near the collection point, a strategy that is very, very powerful when synchronized with larger footprint databases in the cloud. And that has been everything I have to say about micro frontends for now. Thank you very much. You can catch up with me on Twitter. We can continue the discussion and the conversation over there. I hope you have enjoyed, and thank you.
Thank you very much. Let's see if we have any questions from the audience. Let me check the chat. If you have any questions,
turn on the light because it's off. Yeah, sorry about it. The sun went down as I was speaking, and I don't have it like.
That's all right. It wasn't too dark.
Okay.
I don't see. We don't have any questions at the moment. If you have any questions, please drop it on the chat. Thank you very much. That was really good. So, if people want to get in touch with you, like they just message you on Twitter.
On Twitter, on LinkedIn, or yes, just around. Thank you so much.
That's okay. Where your talk is recorded, so it's gonna get uploaded with all the other talks when we finish. Yeah, don't see any questions. So thank you, and
Thank you.
that was really good. Have a great Saturday, and yeah,
Yeah, you too. Bye bye.
yeah,
See you.
bye. So that was the end. So that was the last talk of the day for the web track. Thank you all very much for attending DevFest for this year. And let me see. No, we don't have any questions. You can watch our videos on our YouTube channel. They're all gonna get updated. If you missed any videos from any other tracks, they're also gonna get updated there. Yeah, enjoy the rest of your time, and thank you very much.